maybe. Oh, bro.
Dude,
No worries, no worries. It happens. It happens.
dude,
There we go. Okay, now we're live. Now we're live.
wait a
Yeah,
minute,
nah,
wait a
bro.
minute.
I think now we're live.
That's so weird because
Uh,
I literally said
I think you
it said,
started the broadcast.
but it usually starts automatically, so I don't know why I had to click start stream.
Damn, that's weird. Cause okay, okay. So
Okay,
I think we're live now. We had a little.
yo, Michael. All right,
Hey,
so
Michael.
we were just
Welcome,
yapping.
welcome.
We're just
We were
yapping
just
right now for the past
for the
five
past
minutes.
5 minutes. We were just japping, thinking we were live,
So
but we
thank you,
weren't live.
Jonathan, for letting us
But
know.
thank you, thank you. Yes. All right. Now I can see the stream now on my iPad. I thought it was my thing.
Okay,
All
that makes
right.
sense.
Yeah. All righty.
Well, now
All
I
right.
know.
So
It
okay.
says, it
Well,
literally says, stop streaming, but then it says go live on the right. And then
Brandon, maybe
not
you
only that, it says live,
uh-huh.
and the clicker was going on.
Maybe you had the broadcast on, no? Like you can broadcast it, but it's you're not actually
Yeah,
streaming.
that's what it was.
Maybe that's where. Hey, welcome,
Yeah,
Ali. Welcome to the stream. Welcome to the stream.
that's right.
Yeah.
I was
Damn.
so
Hey, but
confused.
we're back though. We're back. We're back. You know, we in
Okay,
here
so what
yet
were we saying?
again.
What were we saying?
We were
What's
saying
up
we
to
went to the
AB? AB, we said what's up to
steakhouse.
you.
You said we said
What's up
what's
to
up
AB, and
to
then
Jonathan.
Jonathan,
Yeah.
and
Orcas,
then
welcome, welcome, welcome.
Michael. How you doing,
Welcome.
Mike?
Michael Dub, the W, yo.
Alright, go over what you're talking about. You're talking about the steakhouse.
We were talking to steakhouse. We went to steakhouse. It was good. They had this sirloin with cheese. Then they had the with steak with
Chief.
bacon.
Oh,
With bacon, bro. That thing was good, bro. And they had this cheese roast, bro. Oof, bro. That's nice. It was nice. It
yeah.
was nice.
It was really
Yes,
good.
sir.
Recommended.
Yeah, it was
the
good.
End of the semester celebration, if you will.
Yeah,
But,
yeah.
yeah, semester's over, so it's time to get ready for summer classes.
Summer classes, yes, sir. One more
And
week of summer, and we're back again.
yeah, one more week of our break, as you could say.
Yeah,
But
yeah. But we in here, bro. We in here. We're grinding.
okay, volume seems low. We'll fix that.
Okay. Sir, no worries, no worries.
All
Yes,
right.
sir.
Let
Yeah.
us know. Oh, it's my mic. I'm low. Okay. I got
Okay.
you. Let's see.
Sir, hey, thank you guys for the tips. Thank you. But yeah, it was good. It was good. And then
Let me
bro,
know.
the Caesar salad, bro. The Caesar salad, bro. I don't like salad, bro, but that thing was smacky, bro. That thing was good, bro. It was good. Orca says it's a little bit louder. I think maybe. Yes, sir. But today we had some little couple problems that are gonna test
Background
us.
music is louder. Okay. I got y'all.
Oh, that's right. We have background music. That's true. That's true. And yeah, but today just a little bit of what we're gonna do. We have a couple problems. They're gonna take us out of our comfort zone. We're gonna explore some new concepts, some new stuff. It's gonna be good. It's
Yeah.
gonna be good stream. We're gonna have a little
La-
bit of a little difficult concepts per se, but we in here though. We in here.
yeah. We have some dynamic programming, some graphs, and
And
linked
linked
lists.
lists.
Yeah.
Yes, sir. We have some linked lists.
Did you want to
Yes,
go over
yes.
that? Okay, perfect. Yes, that'd be great. You want to go over the comment that Orcus
Oh
said?
yeah. Oh yes. Orcus gave us a comment. I think it was in the previous live stream a couple of days ago that he said that we should, instead of like having one person do all the programming, we should have alternate, right? And we're actually gonna implement that today, where Carlos is gonna start doing one, then I'm gonna go with another one, and then Carlos is gonna finish with a third one. So we're gonna go back and forth, and he's gonna do the typing. I'm gonna help him out. He's gonna do like the coding and stuff. He's basically gonna lead the problem, right? And then I'm just here for support. And so that's where we're gonna do. And the Orcas gave us a comment, and we thought about it, and we felt it was actually pretty good, something that we could try this stream and see how it works. And then hopefully maybe implement it on future streams. But yes, that's what we're gonna do today. And so like I said, Carlos is gonna start off the first one, and then I'm alternate and boom, boom, boom until we finish, or we try to finish for sure.
Yeah. Michael said, do we do any other types of interview prep other than LeetCode? No, not really, but
No,
we're very open to it.
yeah, we're open to it.
So
Yeah,
we haven't really
yes,
dabbled
sir.
into it. So if you could explain a little bit more, like what other types? Like obviously there's like mock interviews, right? Where,
Yeah.
but I don't know if there's anything more than, from my knowledge, I don't know what else other prep other than a mock interview. Do you know? Is it?
No, that's pretty much it. The mock interviews and LeetCode. That's pretty much to my knowledge, you know. But I right now think of one. Not quite. Nah. Nah.
Thank you, Jonathan. I was gonna ask the question right now. Oh, whoa,
Okay, okay.
Michael
System
with the
design
counter.
interview. Ooh, Cloudflare. Ooh.
Cloud on site with Cloudflare and no LeetCode, but basic DSA plan. Okay.
Okay, okay. uh.
And okay.
Okay, okay. I see. So a little bit with design, like system design, object oriented programming design. So like I think interviews that have to do with design. Okay. Me personally, I haven't gone into like what types of interviews is there. Just pretty much LeetCode and the problems they're gonna probably ask, right? But but yeah, hopefully I'll try to do a little bit more research. Maybe in the future, I don't know if Carlos is up to it, we can do like a mock interview. Cause I don't know. We had a subscriber a couple of streams back that he offered the opportunity to have a mock interview with them. So that'd be nice. That'd be nice. Something to have here. For sure, for
Okay.
sure.
Yeah, we're definitely open to it.
Yep,
Another
yep.
thing I want to mention before we start, we're about to start right now, by the way.
Okay. Yeah,
But
yeah.
one thing I would like to mention is that if the stream does buffer, because sometimes in our stream it gives us like a warning, like oh the bit rate, blah 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 blah, and I see like it paused for like a second or maybe a couple seconds, it comes back up. So if you see something like that, let us know because I want to make sure if there's ways to fix it. I try to switch it up today, and hopefully we won't get it for today's stream. But if it does happen, please let us know, and then I'll kind of see how to fix that problem. It's probably my
Yes,
computer,
sir.
but there's no reason why I should be doing that. Just to stream, screen share a site. So I don't think there's any issues with that, other than maybe some settings that I have. But Michael, add us on LinkedIn. Michael, you seem to, you're always in here. We would like to connect, man.
Yeah, for sure, for sure. Yeah, yeah. You can find our LinkedIn's. I think it's in the description, no? If I'm not mistaken.
Right under our faces.
All right. All right. That's
And
so true. That's so
and
true.
in our
Right here. Right
LinkedIn.
here. And
I mean,
our
and in our
and
description. Sorry.
description.
Actually, I think it's in our info page.
Yes, in our YouTube channel, yes,
Yeah.
yes, but I'm not sure if they're on the, yeah, they're not on the description. But if you guys go to our channel, on the information page, you can have the direct link, right? So you click on it, take you to LinkedIn. If not, you can search us up right here under here. But yeah, hopefully, yes, sir.
Hey, not wait. I was about to say 9 is better than 11, but 9 and 11 is not good together.
Yeah.
So just to be clear,
Yeah,
just want to
but
make
now
sure I'm clear with that.
let's make it 11. Let's make it 11.
Let's make it 11.
Let's make it
Yes.
11. I'll gladly make it 11. Ninth grade, if I need to teach you.
Unfortunately, it does. Okay, you ready? I'm ready.
I'm ready. I'm ready. It's you're up first, by the way.
Okay, let's see.
It's
All right, there should be no
alrighty.
background noise anymore.
Yep,
Um,
yep,
this is the first problem of the night or the evening or the morning, or depending on who's watching at what
yep.
location. But we're going to be doing the Fibonacci number. So
Yes,
the
sir.
kind of structure that we have set up, like Jose was mentioning, if I'm going to be typing, then that means I'm going to be explaining at the end, and that means Jose is going to be reading the problem. So
All right. Okay, okay.
since I'm typing, Jose will read the problem, and also let us know if our audio's good, because I know mine was a little bit low earlier. So, and thank you for letting us know. But let us know if it's still good, and then Jose, you're ready whenever.
Yes, sir. All right. So we're gonna tackle 509 Fibonacci number, and it says the following: the Fibonacci number, commonly denoted as Fn, form a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones, starting from 0 and 1. That is, f0 will equal 0, f1 will equal 1, fn will equal f parenthesis n minus 1 plus f n minus 2 for n greater than 1. Given n, calculate fn. Example 1, we're given the input of n equals 2, the output is going to be 1. Explanation, f2 will equal to f1 plus f0 will equal 1 plus 0 will equal 1. Example 2, we're given an input of n equal to 3, the output is 2. So we're given f3 will equal to f2 plus f1, which equals 1 plus 1, which equals 2. Example 3, we're given an input of n equals 4, the output is 3, and the explanation is f4 equals to f3 plus f2, which equals 2 plus 1, which equals 3. So and the constraints are that n is greater than 0 and less than 30. Yes, sir, yes, sir.
Okay. So is it wrong for me to say that this might be easy?
The thing is, I chose this problem because we're gonna do dynamic programming. So, so
You
we're
always
gonna
got to be
do.
extra.
Nah, yeah, bro. I told you, bro, before the stream, bro. We're gonna do a little bit outside the box, bro. We have to expand the horizons.
Okay. Yeah, you're right. You're right.
Right.
So AB says this one's a little bit tricky.
This is
Okay.
a
So
tricky one.
maybe I did say something wrong then.
Nah, no,
Okay.
we got this. We got this.
So we just need to create a full. Okay. So what? Explain what dynamic programming is. I need a
Okay.
refresher. What does that mean?
Okay. So to my understanding, dynamic programming is a way to like reduce the amount of calls in a recursive like function.
Mm-hmm.
So you reduce the amount of recursive calls you make by saving the numbers or the result of a specific function in like an array or something, in which you can like call for a specific data or a specific integer, or specific something, grab it without having to recursively call to get that number. So it's basically you're getting something, right? And you're saving it in a place that you're gonna use in the future. And this like somehow reduces the amount of recursive calls. That's to my understanding. I had a little crash course, like a 10-minute crash course before the before the stream. So I
Okay.
might be wrong, but
Dude,
that's my understanding.
yeah, I need to
Yes,
be
sir.
doing these crash courses, man.
I'll
Like,
send you the links. I'll send you the links.
I'm
I
coming,
got you.
like these problems I'm seeing, I'm blind. Like, I'm just like, okay, like, I gotta get a refresher, man. Like, I
Yeah.
think, I think I need to join you. I need to join you and get
Bet,
some
bet, bet, bet,
refreshers
bet, bet, bet.
because that'd help a lot. But
Yeah,
okay,
I'll send you the links.
so that's interesting.
Yeah.
So, so then basically, if that applies to this problem, you could say you want to dynamically say, okay, f of one, store
Uh
it,
huh.
and then
Store it.
call it again whenever you want to get the sum of like f0.
Uh, let's yes. Somehow, yes. Yeah.
So you store it,
Cause
or
just
do you
uh
store
huh.
the value all in an array and then just get the sum of the whole array?
You
Is that
store the. you get an array of n, right, of n plus 1 in this case, right, and you iterate. For example, you iterate through the n and you check, is this value, do I already have this value in the array, right? If not, you calculate the value and then you save it in the array, right? So in future recursive calls, once you hit the value again, you go back to the array, check if you have the value already like resolved or calculated, and if you do, you grab that value and you use it without having to recall to do the recursive calls again. Yes. Does that make sense?
Kind of.
Kind of.
Yeah.
Yeah. And I don't want to make it a little bit more complicated, but there's different types of dynamic what's it called, dynamic programming. Yeah.
Okay.
Yeah, and there's one where I saw one form where it's easier, where you don't have to use recursive calls. So I don't know if you want to approach that one.
Well, I'm thinking of an approach.
Uh-huh.
Because I got confused now when it comes to you said in the array you're trying to
Yeah.
if you have that number already, just
Yeah.
use that number
Yeah.
instead of. So
Yeah,
you're
'cause if you
so are you saying like after you get all the values in an array, like if it's f of 2, and then you gotta calculate f of 1, f of 0, and then
Yeah. Yes.
So you
Yeah.
get all those values put into array, right?
Uh-huh.
Now you want to get the sum of the array, but do it dynamically.
No. It's because, for example, let's say we want the Fibonacci number 5, right? For 5, we need f4 and f3, right?
Mm-hmm.
For f4, we need f2, f1. Yes?
F4, we need
F
F2.
f3, f3, f2. Yeah, because it's the two previous numbers.
Okay.
Do you get
Yes.
me?
Yes. Yes.
Yes. On f3, right, we need f2, f1.
Uh-huh.
You see how in f4 and f3, f2 repeat? You want to draw it out? So
Yes,
you can
for
make
sure.
it a little bit.
Sure.
Yeah. All right. All right. Let me see. All right. So we're gonna use Excalibur.
Thank you, Jonathan,
So we want
for this website. By the way.
oh, Jonathan. Yeah, he came in clutch.
First, you said I did this one using recursive functions too. Orcus said this one's easy. I did this in a more straight way.
Yeah.
And Michael mentioned I wrote a Go web server that recursively sends HTTP requests to itself to calculate the fib.
But I like, that's pretty cool. That's pretty cool.
Interesting stuff.
Yeah. In recursion, you can easily do it, but and if we come to the point where we cannot do it dynamically, we can switch it up to recursion.
Okay.
Yes.
All right.
All right. So, to my understanding, we have n of 5, right?
Yes.
Right. And this thing, we have to split it into 4 and 3.
Yes.
Yeah.
Yes.
4, you get the two previous ones, which is 3 and 2, and we get 3 and 1. No, 2 and 1. 2 and 1. Yep. Yes.
Yes.
Yes. 3, we need 2 and 1. 2, we need 1 and 0. We need 1 and 0. Over here, we need 1 and 0. Yeah?
Okay.
Yeah. You see how this repeats, this repeats,
yes.
this repeats, this repeats, this repeats?
Uh-huh.
Basically, what we're going to do is create an array, right? Where we for sure know that our first two values is 0 and 1.
Yeah.
Yeah. and then we're gonna say, all right, for the nth term 2, what is 2? Well, 2 is the summation of 1 and 0. So now we got 1, right?
Okay.
And now whenever we hit a 2, like right here, we're gonna go to the array and say, all right, do we have
Two
the
is
value
one.
2, right? Do we have the value 2 already? Yes, we do have the value. All right, so now we replace the number with 1. You get me?
Okay. Yeah. Yeah.
We do the same thing with 3. We go to 2, which we already have, which is 1. 1 is 1. So now 3 is 2. You get me? So now
Yes.
3, because this is the value 3, when we get over here, we already know what the value 2 is. So we skip all of this iteration.
Yeah.
We don't have
Instead
to do a
of
recursive iteration
okay.
there. Because we already did it here.
I
We're
see.
just like
Yeah.
saving it on over here.
Okay.
So now we
Okay.
have it at 3. We just access it, get the 3, and boom. Easy as that. Well, not easy as that, but like that's how like it's like you save
Yeah.
the values,
Yeah.
so you won't have to do all of this, or you don't have to do all of this or all of this. You just
So
grab the value.
okay. So whenever it comes to like inputting into an array, um, how would you know that that value 2
Uh-huh.
corresponds with the function with the f of 3? Or do we need a dictionary to sort of key that type of data set?
I mean, we can do with indices. 0, 1, 2, 3, 4.
Okay,
We
okay.
can do with
Yeah, yeah,
indices.
that makes sense.
All right, we got okay. Jonathan is going all out in the
Jonathan
chat.
with an
Damn,
essay.
with the essay, bro. All right,
There's nothing
so
wrong with that. Let's read it.
starting from the top, first shield. What is the name of software? Michael, thank you. Yes, it's called it's Calidra. Um, yes, AB, thank you. I tried my best with the explanation. I tried my best. And you want to take it on, Jonathan, Carlos?
Oh, okay. All right.
Yeah.
Jonathan said two main types of dynamic programming: one top down, two bottom up. So for
Uh huh.
top down, we write the recursive functions as usual, but save the results in a memo in the memory, right?
Mm-hmm.
For
Yes,
example,
in a rate. Yeah.
when we call fib4, we'd save the result to memory 4.
Mm-hmm.
Okay, 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 okay. Then if we ever call fib4 again, we could use a value in the memo instead of recursing downward. Okay, that explains.
Mm-hmm.
And then for bottom up, we get rid of the function. And keep track of the previous numbers in an array. Then at each step, we could just use the previous values. So for Fibonacci, we will get the last two. And then lastly, he says there's another way to do bottom up that saves more memory, but I'll let you guys figure that one out.
Okay.
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 I understood the top down. That one.
The top
That's
down.
basically what you
Okay.
explained, right?
Yes. Yes.
Okay. Bottom up.
For the bottom up, we forget about the recursion, and we basically have an array right here
Okay.
where we have say for two values, 0 and 1,
Uh-huh.
right? And then let's say we want to find 5. So we create like a loop, and we say, alrighty, somehow get these two, right? Get a position, let's say n-1 or whatever. N minus, let's see, I'm not really sure how the logic will work, but let's say, let's just say we get 0 plus 0, 1. This thing is going to be saved right here. So it's going to be 1.
Okay.
Now, next iteration of the for loop, we're going to use the same logic to grab 1 and 1. And we're going to save it here. Do you get me? So we're just getting the first two values of the array, and we're saving it on the next index. Then we grab the two values, we save it on the next index, all the way to n. And I think I got it. I think the value, the for loop I think it's a while loop.
Wouldn't this be like the most common way? Like you're just adding up until
Yeah.
5.
Yes,
But
it's I
instead
think
of,
it's
but you're just storing the last value,
exactly
and
yes.
then
In the
doing the calculation for the next one and
yeah,
adding it to the last
yes,
value. Right?
yeah,
Okay.
yes, yes, yes. And the advantage of this is that you don't have to use recursion, so you don't have to use stack frames or anything like that, so you won't
Mm-hmm.
run out. It's just more in here. But I think the logic of this is that um wait for loop think is it has something to do with three because it's 0, 1, 2, 3. This is actually 4. We know I think it's n we equal 2 while I is less than 4, right? Because this is index 4, we want to find this one.
Okay.
So n equals 2, n minus 1, n minus, I think it's 2, if I'm not mistaken. And I think, let me, if it's messy, I apologize if I'm confusing you, but I'm not really, I'm not really sure how this thing is supposed to work. So I'm just coming, like getting it from the top of my head, right?
Well, wouldn't it
So,
be like almost like a variable that holds the value of the last sum,
uh,
and you just keep changing that variable, and you just move to the next one, and you do.
I mean, you can do that. Yeah, for sure. You can do that. Yeah, 100%. But the thing is that you have to get the two previous numbers, if that makes sense. Because n we equal this, while I, yes, I think so. Like this. Do you get it?
Kind of. I
Or you
just
want me
don't
to?
know why n is two.
Okay,
Uh,
so n is 2 because we
because
need
we
to start
know
this value. Because we
we
know,
already know 0, 1.
yeah, we know 0 and
Okay,
1.
and
Yes,
then
n has, go
4
for it.
would be the value that they give us.
No, the 4 is the value that that we want to find. We want to find the fourth value.
But they give us that value in the problem, right?
No. Oh yes, yes, yes. They give us 4. Yeah,
Okay.
they give us 4. Yeah, yeah.
Okay. So we want to go
Yeah.
until it hits that value,
Yep,
and
yep.
then where do you store that? Where would you store that? The value of n.
All right, let's call this memo, like as memorization, and then we can go right here and call this memo at n. Memo at n,
Okay.
like this. So basically, um, so basically here,
N is 2.
yeah, n is 2. So we go, is n less than
Okay.
4? Yes.
Yeah. Yeah.
And so we're gonna access the previous 2, which is 0 and 1,
Uh-huh.
which is 1, and memo at n, which is 2, is equal 1, and plus plus. So now we're looking at 3, right? 3 still less than 4. Memo 3. So we're at this index right here. We're gonna get 3 minus 1, which is 2, which is 1, right? You following me?
Yeah. I'm following.
Yeah. Then we're gonna go 3 minus 2, which is 1, which is 1 again, which is 2. 4. 4 is, I think it has to be greater,
Equal.
equal. 4, now n is 4. 4 is less than or equal to 4. Yes. Memo 4, which is this one right here. 4 minus 1, which is 3, which is now 2. And minus 2, which is 1, which equals 3. And that's how, and you return memo at 4,
Okay.
like this.
So this is still technically dynamic.
Yes, because you're saving the values.
Okay.
Yeah.
Okay. So that's the main thing that stumped me was dynamic. I don't think I've worked with the problem like
Yeah.
thought of a solution using dynamic programming, nor did I remember what dynamic programming meant. So
Yeah.
okay, so
Yeah.
that gives me a better
That's
understanding.
that's an approach. We can do this approach, which is easier, you're right, or we can do the recursive approach. This one. Oh, this one right here. You tell me. You choose. You choose. You lead this one.
Honestly, I like obviously the easier one's pretty nice, but I like the recursive one
You want to do the
where I
recursive
thought it
one?
was a little bit more challenging.
All
So
right. To be honest, the recursive one. That's where I'm like, this is a little bit,
well,
But
let's see. Let's
I'm
see.
down. I'm down to try. I'm down to try.
So you
We
said
got
you're
we
gonna
got the
start
chat here
from the
to help
top.
us. So.
Well, Michael said looks good to me, and Koro just said the exit is N.
Exit is N. It's because I think there was another comment before that I don't know if the user deleted it, but it said like something about like the exit condition, like if we were in a recursive call.
Oh, okay.
So
So it was
yeah,
referring to that.
yeah.
Okay. So okay, let me get a refresh on this one. So N is given to us, and then um, we're gonna this one we're gonna do top from bottom. Is that what you want to do?
I think that's top down. Yeah,
Top
top
down.
down. Yeah, because you
So we
start
do
from the top
5,
and go down.
and then you're like, okay, what? Well, 5 is gonna be N minus 1 and N minus 2, and then what is N minus? Then you gotta figure out what is N minus the value of N minus 1,
Mm-hmm.
which would be 4, and then
Yep.
you gotta see, okay, what's the value of that? Okay.
Yeah. And
So
Michael, oh, sorry. Michael, I think it was Michael that deleted his comment, but he was asking us. Sorry. I didn't. I didn't know it was a question. Apologize. Sorry.
oh, okay. Hmm.
Yes, sir. All right. I'm
Now
good.
that
I'm
I'm
good.
thinking about it, so do we calculate the one that reaches the bottom first?
The 1 and 0.
Like like the like obviously like the different paths, um,
Uh-huh.
they're different. So that's shorter to 0. The shortest to 0 is gonna be if you take a right and go down the 3, right?
Uh-huh.
And you get to 0
Uh-huh.
quicker than if you were. But you need to go the longest way so you can get all the values, right?
I think so. I'm assuming. Yeah.
Yeah, this one has
Yeah.
some. Oh, hard to think about at least. Okay.
Yes.
4, and then 4, and minus 1, and minus 2, and then 3, and minus 1, and minus 2, and then 2, and you keep going down to the bottom,
Mm-hmm.
and then how? Okay, well let's try it.
Let's try it. All right.
Try it.
You wanna? All right. Okay. You go for it.
All right.
Sir.
So we want to do top, bottom, recursive.
Oh, that's so true. I forget. I had to switch my. Okay.
What's up?
No. I'm
good?
good. Yeah.
Okay.
All good.
Always start with the base case. Always. Thank you, Mike. So, base case. Base case is when n is greater than 1. Make sure it's
When I think when n is base case. Okay. I think we're gonna have a like multiple base case, because we have to check if. I know for sure one of them is gonna be when n is less than or equal to 1, return 1.
because
Yeah,
we're trying to get those 0 to 1 values, right?
Yes.
So when let me see.
Yeah, I think so. But no.
I mean, base case is
Yeah.
does it say right here?
No. I think our two base case is when n equals to 0, return 0. When n equals to 1, return 1.
Okay.
Because we need those first two values.
Equals 0. Return 0.
Hey, thank you, Michael. Thank you, Michael, for the tip. Thank you, appreciate it. Yeah. And then,
You can still see my screen, right?
yeah.
Okay.
And then from there, we go base case. We go n equals 0, return 0. Yes, return 1.
And then,
Yeah.
okay, so we're starting with n, and then we're checking is n equal to 0 or n equals to 1, or do we do separate if statements? No, you can't do or because they're both going to be a different.
Yeah. Yes.
So.
Okay.
You gotta have two separate if statements, right?
Yes. Okay. So when n equals to yes. Now to tackle on the. Okay, this is gonna be hard.
Then you do. Do you call? You gotta call n minus 1 and n minus 2, right?
Yes.
If n less than 2, return n. If n less than or equal to 1, return n. Oh, do 1. Okay.
Yeah. Okay, that'd be better. Yes. Jonathan and Michael said basically the same thing. Yeah. Like the both when statements that you wrote there, it could be simplified to if n is less than n, return n, or if n is less than or equal to 1, return n. But both of them work.
I gotta
because 0 is less than 1, right?
Yes.
So you're gonna return 0. You get me? So 0 less than or equal to 1, return 0. So you either way returning 0. If 1 is less than or equal to 1, return 1.
But how would it work for if it's... So
because if
n is 1,
yeah,
you return...
is 1.
And... Oh, okay, and then it keeps going down. Wait, if n...
Yeah, because it's... Either way, it's going to return the value of n.
Okay. I think I'm good.
You get me?
I think I get that.
Okay. Hey, thank you guys for the tips. We're on our highest viewer count for a stream today with 15 viewers.
15?
15. So if you guys are brand new here, drop a subscribe, drop a share, drop a like. You know, trying to grow this channel a little bit higher. So we in here. Alrighty.
The constraints Orcus is 0 less than equal to n, and n less than equal to 30.
Yep. Yeah.
Okay. Breathe. Okay, now.
Okay.
We got that. Now we want to, now that that's the base case, do we, like I mentioned earlier, do we call both of those, you do the sum of n minus 1 and plus n minus 2?
Okay, so here is where the memorization is going to happen, because we have to save the value. Okay. So if we don't have the value, we have to save it.
Yeah.
So we're going to go base case if n is less than, if you want, so you can be a little bit clearer, under the if statement, return n. Under like the if statement, you can put return n.
Oh.
Yeah. No worries. You are good. Yes. And then.
Do you want to calculate the sum of the?
Yes.
The n minus 1.
Yes. So calculate. Yeah. There you go. Yes. Alrighty. So. And we're gonna save the result. give a variable result equals n minus 1 plus n minus 2. So the sum of those is going to equal to the result of the summation.
Okay.
Yeah. Okay. And then
Then
that variable, we're going to save it on the
into the
memorization,
memory.
into the memorization.
If it's not in. If it's not
Well,
stored.
well, before, that's where we're missing a base case.
Before. Okay.
Yeah, before, where we're gonna, yes, on if, no, on top of if, I think. Yeah, right there. We're gonna say if let's call this memo the array. So to follow Jonathan's tip right
Okay.
here, we're gonna call it memo at n.
Okay.
Yeah, like n equal to 0, right? Return, if it's not equal to 0, return memo n. So you guys can verify this. I'm just talking a little bit here.
If it's not equal to 0.
Yeah, because we're gonna have an array all of zeros, right? Because they're, for example, null values. They're null, pretty much. So each time we what's it called? Each time we, let's say if the value is equal to 0, right? We check if it's less than 1. If it's not, we calculate the sum, and then the result, we're gonna save it at n. You get me?
So,
Now
so
it's not
this
equal to
is
0.
this is assuming that all the array, the elements in the array will be 0.
Yes.
So then we're checking if it's not equal to 0. That means it's storing a value that we stored in there previously.
Yeah.
Okay.
Yeah.
Return.
So, guys.
Return
Okay.
that.
Yeah.
And then. Okay. That's in. So you would
That
just
makes
need
it a
that
bit.
though. That does make a little bit more sense.
Yeah.
But you would just need that if statement.
Yes, I think so.
Specify anything else.
I don't think so. Okay.
Let me write that down.
Yeah. So, all right. Memoization, not memorization. The CS term is, yeah, memoization. There you go. Memoization, not memorization. Memoization. Each time we iterate. What do you mean, Orcus? Each time we iterate.
Okay. Now we gotta add the result into
the
yes
n. Into the, yeah, which is memo n equal result. There we go. Yes.
Okay. And then I'm still trying to remember last time I was I just couldn't visualize the recursive thing.
Yeah.
But I'm getting a little better at it. So once this ends, now it's going back up.
Yeah.
Right? After this, we already stored it. Or should it be going down? Oh, no. No, then you call the function again.
What do you mean?
Like once you store it, now you still want to go down though, right? Like recursively?
No, because on the n minus 1, n minus 2, you're already branching out. You get me?
So after line 20,
yeah,
do we want to go back up the recursive calls? Or do you want to go down to keep going down to n minus 1 or n minus 2? Or is it doing it right here?
I think it's doing it right there. We're going down. On the n minus 1, we're going down. N minus 2, we're going down. So we're going down into the different branches. And we're saving each of them.
Okay,
on the memorization.
So then keeps going down, and then it reaches to the save. It reaches to this.
Yes.
And then it goes back up.
Yeah.
And then it checks if that, then just return that. I see.
Yeah.
Okay.
Yes.
So this needs to be it needs to be the function. What do you want to call the function? Oh, is it fib?
It's fib.
Or That's what they defined for us, though. Didn't
You
they
want to call
define
it
it wrong?
call it fun. Fun. Yes, sir. Just to um call in the chat. You ask for what's the word, but never mind, Jose. Or I'm sorry, Orcus. Sorry. Uh, I was a little bit confused. But Michael, Coroges, have you initialized memo? We have not. We have on memo right there.
Yeah.
Yes. So,
We
yeah,
didn't, but I saw it and I did it. So thank you for
yeah,
reminding us.
yes. Yeah.
So
Are
this
you guys
should.
doing recursion or iterative? We're doing recursion. Yes, recursion. Yes. And if that was your original question, Orcas, we're doing recursion. I don't think we're iterating. And why do I feel like this is gonna increase in time and space complexity? Um,
Yeah, it is, right?
yeah, I think so.
And it's
Yes. Because
recursive.
yeah, I think so. To my understanding, it is because we're calling the recursive call just call takes up space. But yeah, Orcus, yeah. After we're done, we're happy to see your solution for sure. And we're doing it this way so we can, because well, me personally, my idea was to learn dynamic programming because it's a topic we trying to like we have avoided a couple times, right? But I felt like today was the day to tackle it and see where we could go, right? But
Yeah.
so yes, maybe this is gonna increase the time and stuff, but yeah, so that's why we chose it so we can learn a little bit about memorization.
Yeah. This is my first time trying it. I'm glad we did it because I'm learning a lot.
Yeah. Hey, Orcas, you're welcome. Come on, hop in the boat. Hop in the boat. Today's dynamic programming day. So
Yeah.
hopefully we can learn together. All of us.
So if I'm not
Alrighty.
mistaken, this should be
Mm,
most of the things that's needed, right? Because
uh,
there's the
yes.
base case, there's the recursive function calls, and then once those are done and it finishes all the way at the end, you're gonna save it to the array. And the way we're storing, with the way we're indexing it is, oh, you have to with with zero with and
Oh, huh?
of
Yeah,
zeros.
end of zeros. Yes, sir.
Okay, and then that should be it. That technically. Okay,
Alrighty.
oh, Lambda's here. Lambda.
Yes, I saw that. I saw that one. Yes, sir.
Lambda, what's up? How you doing? Orcus said program does not increase in the same level for Carlos, but bugs does. Bro, yeah, there's a lot of things that increase my insane levels.
Yeah.
So yeah.
Courageous gave us a good tip of to use the self.fib as a function.
But
It's, but I'm not sure.
honestly, I don't know how to do that. I've never.
Yeah,
Yeah, we'll need to pass the array
yeah.
or not. Oh, we do need to pass the array, right? Because
The
we're
yeah, because
yeah
every
we
time
do.
uh
We're trying to. Didn't we try that one time where we try to like access? We try to change an array inside of a function, and then whenever we're out
yeah,
of it, it didn't.
yeah,
Okay.
yeah.
Yeah.
Alrighty.
Corogis, I'm gonna be real with you. I don't think we touched those. I don't think either cache or
Cache
self
or
memo.
self memo.
You can add a K word with the default. Yeah, that's foreign. I'm gonna be real, that's foreign.
A little bit, yeah.
Alright, let me know whenever
But I
you're ready.
think I'm ready.
What are you gonna say?
Michael W gave us another tip where we can add memo equals
Into the function
array
itself?
into the function. Yeah, so
You
we
wanna
can
try
try
that?
that and see. Yeah, I'm done.
But we need to initialize the memo though. You can't. Or do we do that outside?
No, but default arrays in Python are nightmares due to storing state before calls. Eesh, I don't know. I think we should try and do it without the self to see where we go, and we'll see.
You
So
want to
like
just
I would say,
declare a new function, right?
yeah, yeah, yeah.
Alright,
I would
just
see,
put
I would see, I would see.
and then you want to call it fun.
Yeah, you can do it inside too. You don't have to do it outside.
But can I do it outside as well?
Like, I think so. Yeah, I'm pretty sure.
Okay. Okay. And then we're passing the memo, and then we're passing in n.
Yes, and I think you don't have to go do the equal array. You could just do the memo. Yeah, like that.
And are we returning? We're returning. We don't have to return anything, right?
We
We're
have to
just.
return the integer.
Oh yeah.
Yeah, I think so. I'm not sure. I'm not sure.
Yeah. No, no, you're right. We're returning the n. Okay.
Okay, so Jonathan gave us a tip. He said don't need to pass the memo to the function if it's outside. So we can pretty much access the array if we declare the array
Outside
outside. Yeah.
the
So that's
class
why
or outside the function itself.
outside the
Outside the
function.
function. Okay.
Yeah. So that's why I would say like do the def inside fib, if that makes sense. Do the fun inside fib, or it's your call. Let's try like your way. Your way. You lead.
Okay.
You lead.
Okay.
Go for it. Go for it. Yeah, yeah.
So, whenever it comes to initializing it with n, do you want to just do 0 times
And yeah.
n?
Yes.
How
Yes.
did
Yes.
you do that
Yes.
last time? You said
It's
this
memo we
this
equal
0 times n.
times. No, I think it's in the outside times n. Like
Oh,
outside the
okay, okay,
brackets.
okay.
I think so. I'm
Yeah,
not sure. I'm not sure. Yeah. Right there. Yes, sir.
okay. I think didn't someone mention like why do we do it like this all
Uh,
the time?
but we don't have n declared though. If
Yeah.
you get me.
Yep, yep, yep. Yep, 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 yep. Okay, so this is all.
Yeah.
I'm not gonna mess with that. Let me do it here. All right,
Yeah.
bang.
And I think
then
we
let's
do.
move this. Right? You want to do it inside?
Yeah, I would say so. Yeah. All right. I won't get any more in your way, bro.
No, no,
You do
that
you.
makes
You do
sense.
you. Alrighty.
What happened? Why did it run? I didn't. All I was doing
Didn't
was
press it.
press enter. I guess. Okay. Now that we got that, we're gonna put all of this in there, right?
Yes. Yes. Yes.
Bet, bet, bet. So then we're gonna have check to see if we have some store. So if
Oh, control enter submits. That's why it ran.
okay.
Jonathan gave us. Yeah. Thank you, Jonathan.
What
Thank you.
about
Thank
run?
you.
Oh, control enter.
I think it's the apostrophe.
Yeah, I must have clicked it. Okay. And not equal 0. Something like that.
Yeah. Yeah.
And
Yep.
the base case, if and one of the base cases, or
Yep. Yep. Yep.
equals 1, turn and okay.
Yeah. 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 Yeah.
So, will this count as a base case too?
Yeah. Both of them are base cases.
I'm just gonna comment as I go.
Yep. Yep. You do you. You do you.
Lastly, we want to do result equals fun, and then we're going to do memo n minus 1 plus fun n minus 2, something like that.
Yep.
And then
We go.
then from there, we want to save result into the. We want to save result into the memo. So memo at n equals result.
Yes. And if you want, I think if you do return memo n after the last line, it would give you the answer.
Okay.
Huh?
What'd you say?
Like put return memo n. Yeah, like that. I think that will work because you're returning the last one since it's already calculated. So you go back up.
And then, okay, so then we would call the function
The yes with
and
yes.
that,
And if you want, you can print it out.
and then we return something like that.
Or you can just do return fun.
Oh yeah. Oh, you're right.
I think so.
I forgot you put that thing at the end.
Yeah. Okay. All right.
So
Run it
memo
first.
n,
Run it first.
memo n would be at. Let's see. Hold on. I'm a little iffy about this one for a second.
Yeah, for sure. So we had some fellow haters, some OP haters. The what's it called? Object-oriented programming. They're haters. Some here. No worries. We got I've worked a little bit with operating with object-oriented programming experience, and it's not fun for sure. But I'm not really. I don't have that much knowledge to say that I'm one way or the other. So I'm gonna trust your opinion, guys. For sure.
Return memo n.
Uh-huh.
Return result. M equals result. Return. Okay, yes.
Yeah.
Result, memo n equals result, memo. Yeah. Okay, I see it. I think so. I'm not trying to start
I think so too.
a holy one here, but you're one step wrong. Hey, chill.
There were some
Let's
shots,
run it.
bro. Shots fired.
AB says run it, so we run it. Oh.
Yeesh. Out of range. Oof.
And
Do n+1. I think n on the memo on top on the initiation. Do n+1. On the top. I
on
think
the
so.
top.
Yeah,
This
where
one.
you initialized it? No, on top.
On
Where
top.
you initialized the
Right here.
on the memo.
On the
Memo equals 0.
Yeah.
Yeah, n+1. I think.
N plus 1. Okay.
Yeah. But do parentheses on the n+1.
Bro, this bug's about to. Oh. This bug's about to make me upset. Oh my.
Hey! Yes, sir.
N plus 1. Alright, you ready?
Yeah, I'm ready, bro. I'm ready.
AB,
Control
you ready?
enter.
Should I do the shortcut? I'm gonna do the shortcut. Control enter.
Let's go. Yes, sir.
Good stuff, everyone.
We
Good
in
stuff,
here.
Jose.
We in here.
Good
Hey,
stuff,
now,
good
are
stuff.
you, buddy? Are you?
Dude,
Let's go,
don't be
guys.
saying
Let's
on
go.
me, because I was literally just following.
bro.
I was learning. You were literally teaching me. You're the teacher. I was a teacher's pet.
Nah, bro. Nah. We're both learners here. I was learning too. I was learning on the way.
Oh, look at what
Oh,
Orca said, man.
Orcus, okay. A
You
equals
make me
0.
not
B
feel
equals
good
1.
about myself. There's just one line.
Yeah. Hey, thank you, Lambda. But Orcus, I think that's the what's it called? The bottom up solution where you have your start with initialize with your 2 and 1, then you calculate the third, then you use the
Oh, it's not
previous
one
2
line.
calculate.
Sorry, Orcus. My bad.
Eesh. Yeah. But I think that's I think Orcus mentioned before that he would approach this problem from a button up perspective.
Uh huh.
But But hey, Orcus, thank you. Hopefully,
Good stuff.
you followed us a little bit, and we were able to learn something about us too. You know, yes, we tried our best, to explain here. So, hey, that's what we're here for. Learn different ways.
Okay,
It's
before
just
before I explain it, and we go into our next problem. Um, I'm trying to figure this out right here. So, n plus
because
one. Why do we do that?
it's because it's like Lambda was saying, the off by one errors. It's just the stuff that didn't start getting indexed from zero. It obviously it's because we start from zero, right? It's just indexing. Since we start from zero, and we'd say five, right? We go zero, one, two, three, four, right? We need that
Oh,
fifth one, that extra five. So that's why you do plus one to get that extra number, the extra index to get the plus five.
oh, so it's not as simple as just times five, and it'll do five
Yeah,
different
no, it gives
elements.
it gives it gives you five different elements, but we need that extra index because we have zero, one,
Oh, it's
two, three,
four. Okay, okay,
four.
okay. I see. I
We
see.
need the fifth, and yeah. All right, so
Michael. Okay, you
Courageous,
go. You
check
go.
out. All right, thank you. Check out Cache, proper way to tackle more complex DB problems. What is the Cache? Is that a website or something?
I have no
Lua is
clue.
the only one to fix this. They started indexing from one. Yeah, okay. So Lua, you see how Lua, I think it's a language starts from one. Okay. Can you share the solution in Discord? Yeah, for sure. Yeah. Yeah, for sure. Go for it. Class solution. Okay.
I'm a Neo Vim user.
Ooh, bro. Hey, Carlos likes Vim. He's a Vim lover. He's a Vim lover.
Hey, chill, chill.
He's starting to like Vim in the command line and that stuff.
You're saying too much, man.
I'm saying too much. Hey, bro.
Um,
Alrighty. Let me
hey,
see.
Orcus. You know, just you could do coding blocks. If you didn't know, it's the three little. I believe it's what is it called?
The escape thing. The escape. I think so.
These.
No.
If you use those three, you can create a code block in Discord.
The those. I'm
FYI.
gonna put them in the chat.
Backtick. Okay, yeah, backtick, backtick.
Yeah, those. Sure. You. I think you can. Yeah, like Carlos said, you can do like a code block. So, and I think somebody else wanted to share. Michael, you're welcome to share your problem, your solution on the general chat, like Orcus did. But yeah, like Orcus put it on the Discord. It's the button up. Yeah, for sure.
We put it in coding help. And
Coding up.
also,
Okay, coding up
we
on the
saw
channel
your
coding up.
message, Jonathan, about the daily Boolean binary tree. Should you move it? Nah, don't worry about it, Michael. Don't worry about it. Not a big deal.
No worries, no worries. Yeah, coding help. Where's the coding help? I didn't. Oh, I see. I see. Okay, I see. Uh,
For other
okay.
viewers that are in the Discord, if you want to join, the link is below, I believe, in our description. There's
Yeah,
only 100 uses, so
100 uses.
just to
We're
kind of
running out.
soft
We're
launch
running
it.
out. We're running out.
We're not running out.
We're not
That's for
running out.
sure.
We have plenty. We have plenty of space.
I think maybe like 10 or 11 people have used them.
Yes,
So
yes.
add the
So
add cache guy. Oh, I'm confused. Can we explain what the cache? What are you talking about? I'm so confused.
okay. So
Here, I'm gonna move to the
Jonathan,
intro and
thank
outro.
you.
Did you want me to explain it real quick?
Yeah, for sure. Go for it. Go for it.
Okay. All right, I'm gonna explain it real quick, and then we're gonna go to our next problem,
All right. Yes,
or
sir.
we're gonna review some more code from the Discord, and then we'll go to our next problem.
Yes, sir.
Okay. So for this Fibonacci number, we wanted to do it dynamically. And to be honest, I didn't know really how to do that before we started, but now it makes a lot more sense. Thank you, Jose.
Yeah,
Um,
of course. That's what we're
so
here
it,
for.
it looks fairly simple, but it wasn't coming up with it. But we want to do a recursion to get the Fibonacci number. So whatever n they give us, we want to do it recursively and sum up everything. And with that, we needed two base cases. We needed one where it sees if there's a value stored in memo, which is our initialized array that is initialized with zeros times n plus 1. So this just means it initializes the array with n plus 1 zeros in it, so elements in it. So we check right here on line 26, we check, okay, memo n, if it's not equal to 0, then that means return memo n. Since it's not equal to 0, that means there's a value stored to it in which we've previously added into that array. So instead of redoing the sum of that value of n, you just use the last value we had stored in that at the end index, and we return that. So it saves us. I guess it was technically save us memory, right?
Yes,
Or
yes.
time, right?
Memory, and it's more efficient. Yeah.
More efficient. Okay.
Yeah.
After that, our last base case is when n is less than or equal to 1. This is because when the first two numbers of the Fibonacci are 0 and 1, so this one kind of helps with that to make sure we don't go anything past like -1, -2, or anything like that. So then after we got that set, we want to do our recursion call. So we do our recursion call to the variable result, and we do n minus 1 and n minus 2. This is the formula that was given in the description, and that's how the Fibonacci runs. And then we store the value of result into memo n. So that basically does what I was mentioning earlier when it comes to this if statement, is that if there's a value other than 0 set to memo n, then that means let's just use that instead of redoing all the calculations and stuff like that. So it's almost like your future self is doing the work, and you're just grabbing the info they did and then using it in the current, right? That's kind of how I think about it. Is like your past self did it already, so just use it instead of doing the work again. Something like that. So
Pretty much,
anyways,
yeah.
something like that. So then after that, you return memo n. That's whenever you made it all the way to the end, and you start calling back. You start going back the chain of the function calls, and you just return that number, and it keeps adding, adds to result, keeps adding, and then from there, at the end, you will have the last sum of the Fibonacci, and then you just return that outside that function. I hope I explained that a little bit good.
No, it was good. It was good. It was good. For sure, it was good. I liked it. I liked it.
Appreciate
Yes,
you.
sir.
Appreciate you. Okay.
So,
we're in our intro / we're in our like.
Alright.
We could. You want to adjust our insane levels? What do you think?
Before that, Jonathan, Michael, and Orcas gave us a definition of what cache is.
Okay. Where?
So, on the chat, it's on the very bottom. It says, so for Jonathan, it says if you add cache above a function, it will automatically store the results of functions for you. Okay, so basically, so this is for Michael. Basically, if a function call gets the same inputs, the cache is used to avoid computing those inputs again. And from Orcas Python, add cache is a decorator provided by funct tools module that enables memorization, a form of cache for pure functions. That's interesting. I didn't know that. Okay,
Look at that. We
okay.
had 3 different people give us a definition of
Definition
the at
of
cache or
cache.
cache.
Hey,
Good stuff, everyone.
Hey, thank you guys. Thank you guys. We appreciate it a lot. Thank you guys. Thank you, Michael, Jonathan, Orgus, and everybody in the chat who was supportive in this problem. Thank you. Thank you.
Hey, Michael's critiquing you, man.
Yeah, bro. Come on, Michael, bro. Come on. Nah, it's all right. It's all right. So pronounce it as cash, not cachet. Cash, cash, cash.
What if you're from like you were born in like France and you want to say cachet,
It's a cachet.
cachet, whatever.
Yeah.
Okay.
So it's right. All
You
right.
ready to do
So,
the update our levels or what? What are you thinking?
yeah, for sure, for sure,
All right.
for sure. First, you go first. You were the
We
one that was
respect
programming.
we respect the game, as y'all know,
Yes, sir.
the game of LeetCode. So, but of course, when you play a lot of games, sometimes you get a little frustrated. Sometimes you get a little annoyed. Yeah. Like I know whenever I play Fortnite and I'm losing, or my teammate doesn't kill a person, or I get downed, or a grenade, or whatever. There's so many ways to get annoyed in the game of Fortnite. But what I'm saying is, just like that, the same way you can get annoyed with LeetCode. And maybe there's some outside factors that could get you annoyed, like some bugs flying across my face and thinking they could like taunt me, and you gotta swipe at them sometimes. So there's a lot of different things that could get someone annoyed, but in this case, it's LeetCode. So based off my insane levels from this problem, my brain doesn't hurt. I'm not gonna lie to you. It doesn't hurt, which is good, because before it would hurt. So I would not. First of all, I would struggle to understand, and it would hurt my brain. Now I'm just struggling to understand, and then that's it. Does that make sense? So maybe my brain has built up some endurance, some programming endurance, and I think that's improvement. All that to be said, I'll give myself a 2.
A 2? Alrighty.
Because although at first I was definitely fluctuating, I was definitely at like a 4, definitely going up, definitely going down. I think right now I'm at a 2. I feel pretty good. Sometimes we get out of the problem and we're still thinking like, bro, like that's upsetting. But I don't think I'm very upset right now. So that would be me. I'm at a 2.
You're a 2? Okay. Yeah. When it comes to me, I'm like in a 1. I'm feeling good. I feel good. You know, I thought the memorization part was gonna be hard and tough, right? But thank you to the chat, thank you to the viewers. It was pretty good. It was pretty chill. We took it slow, easy. You know, it was a nice problem, and like AB said, it was a great warm up. You know, so yeah, we're in here. I think I'm gonna 1, and I feel good. I feel good. Ready for the next one, for sure, for sure.
All right, the next one we're gonna switch to Jose now. Jose will be.
Okay.
We say like you're in control, whatever, but it's a joint thing. So
it's a joint thing. Yeah.
So Jose will be typing, and then that means I'll be reading the problem, and then Jose will be explaining the problem once we complete it. So similar style to this one. Hopefully, it's a little bit more easy to get it going than this problem. So
yeah.
All right. And let me switch the screen real quick, and then I will.
Yes, sir.
Let me see, where are you at?
I think did I share? Am I sharing my screen or did I?
No, I got it.
You have it. Okay.
Whenever you're ready, you can just hide that.
Okay, I'm good. I'm good.
You're good.
Yes, sir.
Hold up. Why is it? There's like a black box. Let me try something. It's not you, by the way. It's just me.
Okay. But, you do you.
Talk to the chat.
Wow. So, yeah. So this next problem is it's a little bit difficult, right? As we have to. I think it's one of those problems that's gonna take us like a good hour to fix.
Hour.
Right? So, I think so, bro. I think so. Because it has to do with grabs and stuff like that, and I chose this problem because it's an easy category and it's gonna push us to another field that we haven't touched in a bit, that we have been avoiding for a little bit, But I think it's gonna be good. It's gonna be good. All right, trust me. It's gonna be
Okay.
fun. It's gonna be fun. Hopefully.
Give me a moment. I switched it, but for some reason, um, there's like black borders around it. I don't really like that. So let me figure it out.
Yeah. No, you do you. You do you.
Do
You
full
do you.
screen on your thing?
Uh, like me sharing?
Like on your Google or whatever,
Oh,
like on your browser?
yeah. Full
Okay.
screen.
Let me see. What's going on with this?
Yes, sir. Do we have GitHub accounts? We do. Yes, we do. We do. I don't think we put the links to the GitHub on our channel or in channel information, but we'll for sure do it. Hopefully by the end of this stream or something, so we can do it. So you guys can have access to it and follow us for sure. Yes.
My GitHub is just my name, Carlos Lopez Jr. No spaces. If you want to just search it now, if you want to, but
Yes. And I think Carlos is following on GitHub, so I think you can like jump into me.
oh yeah,
Mine
I'm
is
following Jose on GitHub. Yeah.
yeah, and I think mine is J Jimenez, some numbers. So if you guys see something similar, I think that would be me for sure.
All right.
I feel this could be a recursive thing where the place where it starts recursive response filters. These filters check if the next cell should be filled in. Okay, yeah. Okay. Okay. So Landon's already giving us his insight of the question. So we'll look at this insight after we go over the problem a little bit. But yeah,
All right.
you ready,
I
Curtis?
gave up on the figure out the black bar stuff, so that's all good.
Oh, okay, I see it. I see the
You
black
see it?
bar. Yeah, yep.
I give up. I don't know.
Alrighty.
It's some UI glitch, or I'm gonna blame it on a glitch. So it's not my fault. That's all I know. I'm just
Bet.
joking. It definitely could be my fault. All right, you ready?
Yes,
Let's
sir.
get it going. Okay, so this is 733 flood fill. This is an easy problem, it says. We'll see about that. An image is represented by an MXN integer grid image where image at index I and J, or I of J, represents the pixel value of the image. You're also given three integers SR, SC, and color. You should perform a flood fill on the image starting from the pixel image SR of SC. Okay. To perform a flood fill, consider the starting pixel plus any pixels connected forward directionally to the starting pixel of the same color as the starting pixel. Okay. Plus any pixels connected forward directionally to those pixels also with the same color, and so on. Wait. Let me redo that. Plus any pixels connected forward directionally to those pixels also with the same color, and so on. Replace the color of all the aforementioned pixels with color. Return the modified image after performing the flood fill. Alright. I'm like I said, if y'all seen previous streams, I kind of just read to read it. I'm not like understanding anything until after. So, example 1, we have the input, which would have a 2D array of the first element, which is 111, and the second element would be 110, and third element would be 101. And so the SR equals 1, SC equals 1, and color equals 2. That means the output would be the first element 222, second element 220, and the last element 201. The explanation for this is because from the center of the image with position SR to SC equals 1, and then which is the red pixel, all other pixels connected by path of the same color as the starting pixel, which is the blue pixels, are colored with the new color. Note the bottom corner is not colored too because it's not a forward directionally connected to the starting pixel. I'm not going to read the second example.
Okay. Fair enough. No worries.
Bro.
Okay.
What's wrong with you?
it's it sounds
Like, what's wrong with
complicated.
you?
It sounds complicated. It sounds complicated, but I think it's doable. It's doable. We we I think, bro. We have to believe, bro. We have to believe to achieve. Alright, bro. Trust me. Trust me. We're gonna have fun. It's joyful. We're playing with colors. Who doesn't like playing with colors? No.
I don't like playing with these types of colors.
Okay, so to my understanding, right, we're giving a source, right,
Okay.
right, which is one
Yep.
in this case. We can only go up, down, left, right, no
Uh-huh.
diagonals, right? We have to check if it's the same color, if it's the same color, right? For example, if the up one is one, if the down one is one, if the right one is one, if the left one is one,
Mm-hmm.
we have to change it to color two.
Okay.
Yeah. So for example, we will go one, we change it to two.
Mm-hmm.
We go down, that's zero, so we don't
Yep.
change it. We go to left, that's one, so we change it to two.
Yep.
Right? Now, for every pixel, right, that's up, down, left, right of
Mm-hmm.
the center, we have to also look
Check.
down, left, right, up.
Okay.
Yeah. Yeah, for this one, we have to look down, left, right, up. For this one, we have to do up, down, right. This one, up, left, up, right.
And you increment the value.
We
from
change
what
it to two.
Okay.
We change it to color.
Yeah.
Yeah. Yeah. So, like Corogist was saying, this is a problem where we could do BFS or DFS, which is like traversals, right?
Mm-hmm.
Yeah. So I was looking at, I did some research on DFS and
Of course
BFS
you did.
before this. I wanted to be ready because I don't know how to approach this problem. I just
Okay.
know like how to like play around with it, right? But I don't know how to implement this to the problem, right? So we can implement a DFS or BFS so we could so we can like track each of the movements we do and so on and like change them and so on and so forth, right? So yeah.
Okay.
You ready?
Yeah. All right. Well, the good thing is I understand it. Thank you for explaining it.
Yeah.
I
No, for sure.
understand it
That's what
now.
we're here for.
Someone saying, "Is it my voice? Is it my voice? Is that what's low?"
Voice Dinesh. Voice is low. Okay. Okay. So just to read, so we gotta start at image source. Yes. Defining the
Bro.
specified and wait, where in those path pennies? Algos. We can fill it to fill reader space. Okay. Yes. Yes. Okay, both of us. Are we low? Do you think we're low?
Let me
Talk.
see. Yo. I'm gonna try to fix it. Let's see.
I think we're good. Think so?
I just went
But
up
if
3
you want-
decibels. Let me do the other one.
Alrighty. Yes.
Talk.
Hello.
Hello. Okay. Let me hold up. Talk.
Hello.
All right. Think. Okay.
Yes. All right. Danish said,
Hopefully,
good job.
it's a little bit better.
Thumbs up.
Thank
Okay,
you, Denise,
I
for the
think-
feedback. We needed that.
Thank you. Yes.
Okay.
Alrighty. So how to start?
For some reason, I don't believe you, Orcus. Wait, really? Oh, I have like a video before, and it does rainbow, right?
I
Have you
think
done
it.
that?
Yeah. Oh, it does glow. It does turn into rainbow.
No, but you don't have to say like the video though, right?
Oh, I'm not sure. I don't know. It is. So I think you do. Okay. Interesting.
Or is that a little ploy of yours?
I don't think so.
It is true. I believe you, Orcus.
It is true?
I
Okay.
believe
Okay.
you.
Fair enough.
I've seen it before.
Alrighty.
Okay.
So how to start? So DFS. DFS. I was looking to DFS, which is no BFS.
Breadth
BFS.
first.
Breadth first search, where we go where it's implemented with queues. It's implemented with a queue, where basically we go in order. For example, we get one edge, right? And we see where the neighbors are. And we go to each neighbors first, and then we go the other set of neighbors and the other set of neighbors. So we go in order by neighbors, pretty much. You get me?
Yes.
Yeah. Okay.
But
So
in
that's
queues look like that's first in, first out.
first in, first out. Yeah. For example, we're gonna get an edge, right? Let's call this edge 2, right? And it has neighbors of 1, 2, and 3, right? So we're gonna go queue, right? We're at 2, right? We're our start at 2, right? Per se, let's call it, right?
Wouldn't it have 4 neighbors?
It would only have 3 because it's only gonna have 1, 2, 3 as neighbors. These are the neighbors of 2.
Why? If it's an edge, it's an.
Yes, if 2 is connected to 1, 2, 3.
Okay, but if it's the middle, it will have 4.
Oh well, yes. Well, this example is like outside. I'm just like, it's not related to the problem.
Okay.
Yeah. So we got 2, and 2 has neighbors of 1 and 3. So and we're gonna add the queues of 1 and 3. We're gonna add the neighbors of 1 and 3, right? And let's say I don't know, 1 had the neighbor of 1, 4, 5, right? And then once we visit 1, right, we check the neighbors, and now the queue is 3, 4, 5, right? So we pop out 1, we check the neighbors, and we add it to the queue. So you see, like now we go to 3, we add the neighbors of 3 to the queue. So we go like that. So we go we go in order, if that makes sense.
Yeah.
Yeah. So that's what a BFS is.
So.
Is
So whenever you say, can you revert back to the?
Oh, just give me 1 second.
Whenever you say start at 2, how do you access the neighbors? Is it
the neighbors? Node? We exited. No, it's not a node, but it's more like a list. It's a list. Here, it's a list of numbers, like an array. So we just loop through the array of this. If that makes sense.
So give me an example of how.
For example, let's do a dictionary. Right, a dictionary we have the source and the edge and the neighbors. Right. I'm just gonna go neighbors because I don't know how to spell neighbors. And then we have 1, 2. Let's call this 3.
I'm trying to kill the bug, man.
Nah, but poor bug. 2, and then this one goes to 2, right? So we say, all right, let's start at 2, right? We're gonna have 2 lists. We're gonna have the visited, and we're gonna have the queue list right there.
No, so my question is, how do you get from the 2D array to that?
Okay, that's where we're gonna do a little bit of math, right? Because if you think about it, we can only go up or down, left and right. Yeah? Yes? This is yes? So we're gonna have to calculate, for example, I'm gonna switch it to Excalibur, because I feel that way it's gonna be a little bit better to visualize. For example, we're given an array, a 2D array, right? Yeah. Where we have our rows and our columns. We're given, let's say we're given a source right here. We have our 1, or 2, or 3, or 4, or 6, 7, or 8, 5, 4. No. Give me 1 second. I don't know how to count. 5, 6, 7, 8. Yeah.
Yes. Yeah.
Yes. Yeah. So this is our source. Let me put this in another color.
Okay.
Source. This is yes. So we can only move up, down, right, and left.
Yeah.
Yeah.
Mhm.
So in here, we're given also our numbers, our indices, right? Yes.
Yes.
This is yes. So here, if we want to go up, right, since our source is equal to 1, 1, right? How do we go up? Well, we have to subtract 1 from row, right? Yeah, because row, this one right here is 0, 1. Yeah, this
Mhm.
is 1, 1. So we have to subtract 1 from row so we can go up. So up, we know that if we subtract 1 and keep the other one, we're supposed
You'll
to go up.
be okay. Yeah.
We were going to go up. If we want to go down, this
You
is
add
2, 1.
one.
We add 1.
Okay.
If we want to go right,
You add
we,
one to the right.
yes, we add 1 over here. If
Okay.
we want to go left, we go 1 minus 1. Boom. So
Question.
that's a little bit, uh-huh.
We meant Michael talked to us about um, transition matrix, adjacency matrix.
Oh,
This
yeah,
wouldn't
yeah, yeah.
apply for this, right?
I don't think so. I'm not sure.
Because the way it worked was like, can it apply?
Oof.
It
It's because
not
this one
really, because
is.
because 5 is pointing to 2 to 7 to 4 to 5. 2 is pointing to 1, 3, 5. The array
It's.
would look
Uh-huh.
would look totally different than the input that they give us if we're
Yeah,
trying to map it out like that.
and this problem is a little bit weird because we're not given edges. Like we're not given 0, 1,
Yeah.
0, 2. We're given like a graph. So we have to like know where we want to go. So I feel like that I didn't really explore the idea of a matrix, like an adjacency matrix, right? But I did it, so I'm not really sure if that would work.
Okay. Thank
Right.
you for the
And
hearts.
yes, sir. Thank you, thank you. And Michael, dang, my solution source. Hey, no, Michael. Hey, no worries, no worries. It's all good. It's all good. Uh, all right. So Michael answered our question. He said, I think it was the other gent who went over that. You don't need an adjacency list here. You are given a 2D array.
Okay.
Yep, yep. All right. Thank you, Michael. Thank you. Appreciate it a lot.
Okay. So yeah, I really like. It's almost like a joystick when you're like, okay, and
It's
then
like a
just go
joystick, pretty
up,
much.
go
It is.
down, right, left, and
Yeah.
then so whenever it's an edge, the way we would say, okay, you can't go up is that if it's at index 0, like
Uh.
if it's
Uh huh.
0, 0, if there's a 0 in any of the what do you call it? X and
Like.
Y. What do you call coordinate?
Uh
I
huh.
guess you call it a coordinate, right?
Coordinates for sure. Yeah.
If there's a 0 in there or a 2, that means you can't add to that 2. And if there's a 0, that means you can't subtract to that 0.
I would say if we can check if we go negative, if we go out of bounds. For example, over here, if we apply this logic over here, we're gonna have -1, -1, 0, I think, or something like that. You see how we're like out of bounds? So we can like
Yes.
create an if statement. And we say if let's call this x and y. If x is less than r, which is our row or
Mm-hmm.
length row, right? And or if y is less than our column. Does that make sense?
Yeah.
Yeah, a little bit like that.
Okay.
Yeah, that's to my understanding. Oh, yeah, for sure.
I like it.
Yeah,
Yeah,
you want to go through it and see how it goes, how it
for sure.
works? Alrighty. Okay. Hey. All right, but if I confuse you along the way, tell me, because
No,
I'm
I'm
not really
here.
sure.
I'm here with you. I'm here with you.
I'm not sure how this is gonna work.
Surprisingly, I'm here with you.
Yeah, yeah. No, I'll try my best to kind of guide you or guide us to the right direction. But I'm as blind as you.
Okay. AB says repeat your pseudocode and
And
repeat your
repeat your
solution in
solution.
pseudocode.
Yes, sir. Yes, sir. That's what we're gonna do right here. Alrighty. Okay. So. Okay. How do we do this?
So we want to.
It's so it's given a source, right? Source.
Mm-hmm.
We need to go up or down, right? Let's think. Let's think.
Michael, that's funny. Funny, Mike.
Okay. So we're given. Okay. The way I was thinking of doing this, we're given like a move set where we go -1, 0, right? So we can go up,
Mm-hmm.
right? Uh, we're given -1, 0, then to go. Oh, okay. Then to go down. This is gonna be an array. To go down, we go +1, right? So we can go down. If you want to go right, we go -1, right? No, that's to go left. Then to go right, you go 1, right? Like this, something like this. Yeah. You get me? Because these, we're going to use them because now we're given a source, right? So to implement the BFS, right, we need to do visit it and queue, right? Because we need to
Mm-hmm.
know which ones have we visited and which ones have we are in queue. So now I'm gonna go source, right? Which it's given by in this case it's given by 1, right? This is yes.
Yeah.
We're gonna say for I in move, right? We're gonna go for I for m x m y, right? Because we're given two values, -1 and 0. We're gonna say oof, I'm not sure. We're gonna say let's call these x and y, all right, which is our original point. Does that make sense? Yeah. And then we're gonna say
No.
no. All
Mm-mm.
right. Okay.
Okay. Let's see.
Okay.
Where are we at? So go back to the move part.
Move part. All right. So
What is
these
this
are our
for?
moves. Here's where we're gonna calculate our new moves, right? Where we're gonna use this one to move up, this one to move down, this one to move left, this one to move right. You get me?
Okay.
Yeah. Because that's gonna play on when we access the actual -1, 0, 1, 0, 0, -1. Because now,
But
watch.
shouldn't you have it? Okay, go. I'll let you go.
Okay. For example, here we're gonna go. I forgot. X we equal. Wait, I'm confused now. So I wanna. Oof. Because my point was where we can do x plus equal mx y plus equal m my. So for example, on the first iteration, -1, 0, x is equal to 1, right? Yes.
Mm-hmm.
We're gonna get the -1 in here, which is represented by the mx. Yes.
Okay.
So now x is equal 0. Y is equals to 1, right? So we're basically saying, let me write this as 1 plus 1 minus 1 in this case, and we're going to say 1 plus 0, y equals 0.
Mm-hmm.
So now we're given a new point called given by 0 1.
Yeah.
You get me?
Okay.
So now the next iteration, right, we're given 1 0. So this is going to go plus 1 and 0. So this is going to equal 2. This is going to equal 0. Now we're given to 0, which is this one down here. You get me?
Yeah.
And now if we next iteration, we got 0 and 1, which is gives us 1 0 1, which is
Wait. It was 2 0, so that means it's 0 minus 1 for the y, right? On line
for here.
14. Line 14.
Uh-huh.
Yeah, well, before you had it, it was x equals 2, y equals 0, right?
Yeah.
And so then if y equals 0, and the next one we're at in the MOV array
Oh, okay.
is 0 and...
Yeah, but these, because I was going to do it in a way where these values don't affect our x and y. We're just, because, well,
but the
not
next
equal. Like this. Or, yeah, like that. Where we're not like equaling x and y are gonna become those. We're just like trying to see. We're trying to move on the like the.
Oh, okay. So the value of x is always going to be 1.
Yes, 1 1.
Oh,
Yes,
okay.
x
So
is
it's
1,
not
y
always.
equals 1.
It's not changing.
Yeah, that was my bad. My bad.
Okay.
That was my bad. That was a typo. Yeah, sorry.
All right.
So with this one, now the next one, we're gonna go 0 1. We're gonna go 0 plus 1.
Well, then that means that third one is 1 1.
No, because this one, it's gonna equal to this one is gonna equal to plus 0 minus 1. So it's gonna equal 1 0. I was actually missing these things like that. 1 0.
Okay.
Because we get the 1 1 and we get the x, it's a 0, add them up, which is 1.
Yeah.
Negative y, get your y, which is 1, and add this up, which is 0.
Okay.
So now we have our new coordinates, or 0 1 2 0 1 0.
The next one would be the x coordinate would be 1 as well.
Here?
No, the next one.
0 2?
Yeah, it would be 1.
Yes. You're right. Yeah, my bad.
And then
so it's gonna be 0 1 2. This is gonna be 1 again. Yeah, this is gonna be 1. Then 1 1 0 is gonna be here. Then 1 0 2. Yes, these are gonna be our new coordinates.
Okay.
Like this.
Okay.
Yeah.
Yeah.
You with me?
I'm with you.
So now we're gonna do this. We're gonna say, okay, now that we have our new coordinates, we're gonna add them to the queue, right? To the queue. Here's where our BFS gets called, right? So now, right, we start at 1, right? We start at the center, right? That's pretty right? So that means we have visited that part, right? So we get that visited, we get this, right? We get this thing, we compute this, and we're given this 4 new, call this neighbors.
Okay.
Yeah. So now these are gonna go on the queue
Yeah.
because those are new on the queue, right?
Okay.
So now we're gonna say, okay, fair enough. We're in the visited, we got the queue, perfect, right? Now we're gonna iterate again, right? And say, all right, give me pop this one, pop the first one that I have, right? Compute this again, but now on 0 and 1. Now on 0 and 1, right? We're gonna add it, since we're already at 0, 1, we're gonna add it at visited nodes right here. We pop it
Yeah.
off the queue. Now we compute the neighbors of 0 and 1. You get me? A little
No,
bit?
I get you. So it's
Yeah.
the same thing. It's gonna go through it.
It's the same thing.
Throw
Exactly.
it in visited, pop it from the queue. Next one, throw it in visited, pop it from the queue. Okay.
Yes.
I finally killed the bug, by the way.
Mission
Just
accomplished?
Yeah.
Mission accomplished? Yes, sir. Let's go. No more bugs. Yeah, so that's my plan. That's my plan of action.
I like it. It's
Yeah,
interesting.
I don't know if it's gonna work, right? But I'm willing to give it a try and see where we go.
Okay.
Yeah. All right. So guys, if you in the chat, if you guys have any questions about this, I kind of explained it kind of rough, right? But if you have any questions, I'll try my best to answer them. Alrighty. All right. You ready?
Yeah.
Yeah. All right. Okay. Let me move this a little bit back so I can know where. Right. Yeah. So the first thing I would do is to check the bounds, right? Because we don't want to go out of bounds, right?
Yeah.
So we're gonna go. Let's cut this row, capital R. We're gonna say length of. I think
Can you
it's
do a
Fibonacci.
capital?
Can you? I think you can. I'm not sure.
Search it up.
But I think.
don't know. I always thought it was you could. Like as the first one. You cannot start with
a number. It's legal to use letters.
But it's a good idea to begin variables with a lowercase letter.
Yeah. Okay, we can do it with lowercase.
It don't matter.
For sure.
I always thought it was like a sin.
Okay, so orcas. Okay, I'm waiting for the fine explanation after you complete the program. We'll try our best to complete the program for sure, and I'll try my best to explain it the best I can, right, as we go along. And orcas give us, you cannot start with a number and special characters, otherwise it's fine.
Okay, great.
Yeah, yes, sir. So now we're gonna go. I think it's image. We could do image, because that's gonna give us the length of the entire thing, of the rows. Then we can go columns. We can go length image at position 0. I think isn't it parentheses?
I think.
Or is it curly?
I think it would be the same, right? Or no?
I think so.
Wouldn't the length of image be the same as the column? Or is there a way that it'll be 3 rows and then 4 columns?
I'm checking here. I think it's gonna be the same. I think so. It's because it doesn't specify.
Wait, no, it's right. You got it. It's the row, the columns is image I dot length, and then the rows is image dot length.
Yeah.
So would that be the same? Is that assuming that if there's 4 columns, that there'll be 4 rows? I don't think that's assuming that.
No, I don't think it's assuming that either.
So, but
because
it
I
gives it
think it
right
can
there though,
vary.
because if the
Yeah.
image I.length is the columns, like that'll tell you, okay, that's how much elements are in that row, and then obviously we know the row length will be the actual length of the image.
Yes. Yes.
Okay.
Yes. Yes. And Michael, are M and the same? Like Carlos was saying, I don't think they are the same. I think like it could be like a rectangle and can vary in size. Yes. Yes. Alrighty. So now we have our row and a column, right? We can do. Hmm, 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 hmm.
So you
Okay.
start at
We
you want
start
to
our.
start
We need
at
our
the source.
source. All right. Yes. So we had to create our BFS. Create our BFS. Damn, bro. How that has happened to you? Like when you learn something new and you have it fresh in your mind, and you think you know it, but then when it comes to like actually doing it, you forget about it.
Of course, man.
That's me right now.
It's all good. That's what I'm here for.
That's me.
So,
Yeah.
so you want to start at your source, and they give you the source, which would
Uh huh.
be the SR is going to be X, and the SC would be Y.
Yes, I think so. Yeah. 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 The R is your X and the C is your Y.
Okay.
Yes. Yes. Okay. So, I think the next step is to start the BFS. The BFS traversal, which we're gonna do. We need to visit it. Do we? Can we just do it here? Yeah, we need to visit it, which is gonna equal to
And array.
um an array. Yes, which is gonna. I think if I'm not mistaken, we can do it with. No, we have to do it with booleans. You can do it like this. You can do um. Oh, I don't know how this one is gonna work because it's a 2D array.
Why you need to initialize it with stuff?
Because this is a visited, right? And we
But
have
you
to
couldn't.
check.
Can't you just append it to the array?
Uh, well, let me see. Mm, it's because we have to check in advance if we already visited. You get me? Because we are gonna have repeated. There's gonna be instances where we're gonna go to the same spot 2 times, and we have to check if we already visited. You get me? For example, in this case, right? Let's see. On this case, right? On one,
Mm-hmm.
right? We can go left, right?
Mm-hmm.
But this one can also go down, right?
Yeah.
So we need to check if we already visited this value in here. So we're gonna initialize false, 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 false. Then we're gonna go true, true, because we visit these three. Then when we get here, this is gonna be true, this is gonna be true. So we just have to visit this one because we already visited this one and this one.
Well,
If
then
that makes sense.
how would you tell it? Okay, now that's a 2. Like, isn't it good that you're visiting it again because that means it increments again?
It's because we're not incrementing. We're equaling that one to the color. Color can be 3. Color can be 4. Right. So we just have to set 1 to equal to that 4. Does that make sense?
So you start at 1. You go to the
Yeah.
left.
You go to the left.
That's 1.
That's 1.
Okay. Now let's say you did all the other angles or whatever.
Uh huh.
Wait. So you're okay. Give me a second. Let me think it out again.
Yep.
Color equals 2. Why? Remind me again why we didn't go. Why doesn't it go to the right and make it 1?
Yeah, because it has to be the same number as source.
Okay. So same number as source. You go to the left, and then when you go to the left, when you check all the what's it called? Four directionally connected.
Uh-huh.
Then you make those two.
Yes, you make them 2. Yeah.
Okay. So you
Yeah.
check it. You check the next one. You make the source 2, and then you make the left one 2, and you make the up one 2. Now you're going. Now you go to the neighbors. So you go to the one to the left first, and then you check. Okay, is a top one 2? No. So change it to 2. Is the bottom one 2? No. Change it to 2, and then you go back to the other one. Is that one? Is the left one 2? No. If the right one 2? No. And then you change those.
Yeah. You just. Do you get it?
So then that's why I'm wondering. If you're at that one, like you mentioned, so you
Yes,
go
sir.
to the left. You go to the left, and you're checking the one on top of that.
Yes. Once we get here, yes, we're taking this one and this one.
Now, why are you checking the neighbors of that corner one when you know the left one and the bottom one are already 2?
Well, do we know though? We have to check. Because we know for sure. Because from our perspective, we know that those are 2 already. But like the program doesn't know. That's what we check if it's visited. If it's visited, if it's true that we visited, we know that's 2. We've already been there.
I get
You
it.
get me?
Yeah.
Yeah. So we don't have to go there again.
So
Yes,
now,
no.
when it comes to the visited array, you're trying to put false for.
I want to create a grid without false.
Okay.
Yeah. That's where I'm at, but I think I forgot. For I in range of C, if I'm not mistaken. If I'm not mistaken. Let me see. Yeah, I think this is gonna work. Let me see. Let's print it out. Visited. Alright, let's see. Yeah, we got all false. You sure?
Nice.
Yeah. Okay. Yeah, I'm sorry if we chose this problem, dude. I'm really
No, it's all good. It's all good.
yeah, but I saw it and and I did a little bit of research on DFS and stuff, and I don't know. I thought it's gonna be a good problem to learn how to implement BFS and stuff. Okay.
So now that we got those, it gives. Okay. Now we have
Yep.
something where you could change. Okay, true once we visited.
Yes.
But
now we.
Oh no, you're cool. I get it now.
Yeah.
You know where to change it true because it's the coordinates that you get returned back. It's the new coordinates that you get.
Yeah.
Okay, I get you.
Yes. Okay, so now we need a queue, right? Which is gonna be an array, a list per se, and then we're gonna implement queue. We equal to dot append. We're gonna append our source, which is like this, right? Why? No. Or yes, we're gonna not queue. We're gonna do visited. At position source C, we go to true. Like this.
Okay.
Right, because we're in there. We visited. We are literally there. Yeah. And then this yes. So I'm just a little bit of chat because the chat went wild right now. They were having, I think they were discussing about some stuff. Um, okay, AB explain the yes. AB, can you explain the prev like color? I saw it right now, but I wasn't sure what it was. Okay, okay. This is okay. So we got the true, right? Let's see. Okay, now we got true. You see how we got true there?
Yeah.
Yep. So that's where we're starting at. Okay, AB giving some pointers. To perform a flood field, consider the starting pixel plus any pixels connected forward directly to the starting pixel. Okay, for this to those pixels also with the same color. Some replace the color are the. Oh, okay, okay. I think where he okay. I think he in order you know how we said like we have to turn all the ones to twos?
Mhm.
We have to save that color. So we can know because if we switch it up, right, we won't know what the color is. You get me? Does that make sense? Because we need to
Yeah.
keep track of like the one that we had, right?
Mhm.
And we have to like, all right, this one, whatever indices, whatever little square is equal to pref color, switch it to two. Pretty
Okay.
much. Switch it to color. Yeah. So that's like a way to keep track. Thank you, AP. Thank you. Thank you. Okay. So now we have the visited nodes, right? Now we're gonna go with the Q. So while Q, right? We're gonna go. Uh, so why? Okay. So while Q, right? Since we said like we're gonna start adding Q, right? We're gonna start adding to the Q. We're gonna continue until we run out of neighbors.
Yeah.
If that makes sense. Yeah. So, but in here, oops, um,
And shouldn't Q be a 2D array?
um, I think so. Wait, no, does it have to be?
I'm only wondering because if we're putting
Because I
the
think we can.
coordinate, the coordinates.
I think we can do it some like this,
Okay,
where we
that's
append
possible.
just like the thing. But let's see. Let me print it out. If not, I think we do have to do it as a 2D array. Yeah, it worked right here.
Okay, nice. Wait. Yeah, yeah.
Uh huh.
Nice, nice, nice.
Yep. Okay. 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 So, dude, I'm so sorry I chose this problem, bro. I feel like I'm I'm doing a bad job doing trying to understand this.
Dude, this is a first for everything. This is definitely a first
Yeah.
for me.
Yeah, we're learning together though. We're learning. But hey, feel free to tell me and in the chat also feel free to tell me when I'm doing like when I'm going off topic or I'm getting confused or confusing, right? So yeah. Okay. So we do this. So now we have the Q, right? On the Q we have 1 1, right? And we're gonna go while Q, right? We're gonna do I think we can do uh we can do x y will equal to q dot pop if I'm not mistaken. I think we can do something like this.
X, Y. What are you trying to do right there? If X, Y?
No, I want to get the 1 and 1 like the values x and 1.
Mm-hmm.
Yeah, I think I want to but I'm not sure if you can do it like this.
But while Q, I think you specify what you want to pop in the parentheses, right?
BS. I want to pop the Q.
Oh no, I think it naturally pops it in the front. So
I think so. Yeah, yeah,
okay.
yeah. But I'm
But
not sure
but
this
the
is
X
gonna.
and Y thing. Explain that one again. What do you
Because I
want
want
to
to
do?
get the X and Y, so we can add the MXY, the MX and MXY, so we can do this right here. You get me?
Oh, okay. So you want X equals the value of pop, which should be
Yeah,
the 1, 1 to the Q.
yeah.
Let me think.
Let me see. Let me do this. Let's see. Yes, it gave me
Dude,
1 and 1.
what the?
Bro, I don't know,
How do
bro.
you? You're a magician.
Nah, bro, it's Python, bro. It was hit or miss, bro. To be honest, I just shot from the hip. Hopefully, it landed. Jonathan, you can't implement a queue with a standard list in Python, only a stack. Um, mm, okay. Yes. Okay, so according to Jonathan, this queue is like it's not a good queue, right? It's like a queue, works like a queue, but not an efficient queue, right? But it does the same job, right? So I think that's what Jonathan tried to tell us over here.
So Jonathan's saying a stack would be the proper term for what we're trying to do.
Um, uh, I think so.
At least the wording of it
Okay, well, right now you're using is a
as a
stack.
stack.
Okay, so
Yeah.
we're using a stack. Okay. I didn't know. I didn't know. Damn. Okay. Okay, so just rename it. Okay. But I think
That
we have
was
to
that was me, Orcus. Sorry.
but I think we do need a queue for this one. Okay. Okay. Alright, okay, so I think we're gonna stay with this queue because I think it still works. But if not, uh, okay, let's see. Just to make sure. Let's. Um, okay, it's a DQ if I'm not mistaken. Jonathan. Where we can.
Orcus,
Wait,
why did you uninstall it in the first place? Dude,
DQ.
this one's hurting my head.
Is it? Nah, bro. Nah. Let's go.
But
Okay.
thankfully, like I'm still like I see what you're saying with like the idea. I think the only thing I'm struggling with is that color thing, that number
The
line
color.
22.
Yeah, to
But
my
we'll worry
understanding.
about that in a later time. Oh, I'll worry
Yeah.
about it
Okay.
in a later time.
Nah. We good. We'll figure it out. Okay. That a pen. Okay. Yes, that a pen. And then to pop, we can do pop left. Pop left. Okay. So I think this is the proper way to implement a queue on Python. So yes. Okay, bet. Yes. No, is it pop? Yes, this is pop. So I just what I did is just implement a queue so we can like actually work with a queue in Python.
Okay.
Yeah. So pretty much that's all, right? So now we have this, we have a queue, we have a visited, so now we just have to do the following, where we're gonna wrap this into a while queue. We're gonna go pop. We're gonna go. Oh, okay. X and Y we equal Q dot pop left like this. So now we have our X and Y. You get me?
Okay.
So now we're gonna do.
So the left is gonna be um, the last one
Pop.
in.
No. The pop is the first. Like think of a line. The first one is on the left. You get me? Like this 1, 2, 3, 4.
Okay,
It's
so
on the
they're
left.
coming in from the right.
Yeah, they're coming in from the right. Yeah.
Okay.
Is this? Okay. So now we have for I in like that. X, Y equals Q dot pop left. So now we have our X and Y. So for our, let's call this new X, new Y in move. Oh, we didn't implement our moves. Call this. Put this right over here. Right. So in move, we're gonna do the following: X plus NX. Right. If let me see. And if X plus NX, right? This thing right here. What I'm trying to implement.
Yeah. I see you.
Yeah.
I see you.
Is greater, less than, or equal to row, if I'm not mistaken, and X plus NX is greater than 0, and
greater than equal to,
basically
right?
greater. I think so.
Because it can be 0. It just can't be less than 0. Right? If I was understanding correctly?
Yes. Think so. Yes, no? It can be 0. Yeah. So yeah, I think it works like this. Yes, no?
But if you say if it's greater than 0, that means it's going to be 1.
Oh, so it's like
greater than equal to is what I'm saying.
Oh, yeah. Okay, yeah. Thank you. All right, so we have our x's, right? So that's basically checks if it has to be less than r, right?
Yeah.
Here,
or less than equal to r.
Yeah, here it has to be less than or equal to c, right? And x plus y plus y has to be greater than 0. Yeah, I think this works. Not sure, but I think it works.
Okay. Greater than equal to 0 again on the last one, or is it still?
Okay. Oh yeah. Greater than equal to 0. Yeah. And we have to check another one. And how do we check if it's?
Trying to see if it's visited.
Yeah. Yeah, if it's visited. If and
say I got it. If it's say visited, and then put the bracket, and then n plus nx, or you gotta do another bracket.
Oh yeah. Well, okay, yes. Yeah, I get you.
Yeah,
right here. All right. No, this one was supposed to be correct.
Wait, think about it. X and Y. Yeah. So, yeah.
Like this. Okay, this is supposed to work, right? Mm, eesh, 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 eesh. Okay.
Eesh.
Eesh, 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 eesh. Ufas, 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 ufas. You think it works?
Well, we need to have something in the if statement before I could say that. So if it's false, you want to make it true, right? That's what you're trying to do?
Yes. So here it's gonna say, so visit it, all of this, equal true. And Q, wait, yes,
Then you're
Q,
gonna pop. Then you're gonna remove it from the.
no, I'm gonna append it.
Oh, okay.
Append it to, we're gonna append x plus nx, comma, a, y plus ny. Like this. And that's
Okay.
pretty much how we keep our stack.
And then
Our
remove
cube.
one equal sign from the line 37.
Where?
The equal sign.
Oh, yeah. Thank you.
There you
Thank you. Okay,
go.
so this thing kind of works. I'm not sure.
It definitely looks interesting.
Yeah.
That's following the same thing you mentioned above, right? If x plus nx, and the value of nx, where are we getting that from?
From here.
Oh, it's from the loop, the for loop.
Yeah. Yep.
Okay, nx.
Okay, that works. This is fine.
Do you need to put parentheses around that?
Where? This here?
Around the, because you have x plus nx less than r and x plus nx greater than 0. Does that need to, do we need to imply parentheses on the whole thing? Like,
I think so.
like the first 0. Put a closing parenthesis on the first 0.
First 0? Here?
Yeah. And then put a opening right there, and then, well, yeah. Something like, does that help, or will it automatically figure it out?
I think it'll figure it out.
Okay.
Yeah, like Michael said, it should be okay without parentheses.
Okay, good to know.
Yeah. Yeah. No worries. Okay. So now we have to figure out the logic behind this.
Well, you want to run it and see what it gets?
I'm down. Let's see.
So what should it say?
Let's switch the graph. Wait. Yeah. Let's switch the graph. Let's see. Let's actually return of position source. We're gonna equal it to -1. So now each time, you know what? I'm gonna put it over here. To see what we get, and see if it works. If we traverse where we need to, where we need to. Oh, never mind. I didn't do this. Okay, let's see. Yeah, index out of range. Okay. So we're saying, okay, has to be greater or equal to 0. Okay. Let me remove these little equals. Let's see. No, it's still out of range. This is interesting. Very interesting. has to be greater than 0 and less than 0.
I'm thinking about it in my head, by the way. That's what I'm
Yeah, no
quiet.
worries, no worries. No worries, no worries.
Y plus ny. Is it? I think it's the visited.
The visitor note? Right
Yeah,
here?
I think it's
Okay.
that one. So at the very, it could be 3. It'll say 3.
This is interesting.
It's because I think remember how when we were working with nodes that 2 of the conditions were false, but it was still trying to do the last condition test. No,
Oh, yeah.
something like so the first 2 conditions, those are already false, but it's still trying to do the last one, and that it reaches the out of bounds because if the first 2 are false, that means it's out of bounds whenever we try to show it in the visited. Do you think it's something like that?
I think so. I think so.
Like it doesn't eliminate the test, like the if statement.
Yeah.
It still keeps going, and that
Yeah.
would mean that we're gonna reach out of bounds for that last test.
Yeah, I think you're right.
Brie Cheese said, gave us suggestions.
Ooh,
Welcome
what you
back,
said
Brie.
actually. Yeah. I think
Is that what I said?
yeah, you said something about visited right here, about being out of bounds. So I think you're right.
Did we write it wrong? Because that Brie is putting together. But we're trying to access that we're trying to access like row 3, column 2. So I don't think it would necessarily be like that, right?
Yeah, I don't think so.
But that's my hypothesis. Is that
Yeah.
when we reach out of bounds, like those first cases, but it still wants to do the ending.
Yeah.
But I don't know.
Let me print. So it's false. Is this right? Short security in a condition. Maybe it's the image XY. Try removing in line 37. This line right here? Okay, so what you were describing, Carlos, is called circuiting. There we go, circuiting. Alright. So one of our John, welcome to stream. Since you're not doing bounce check after the appended on 38 for the excavation. Okay, so
he's thinking line 34. And then John says not line 37 could be a possible.
Yeah, and I think Michael is also saying the same line 37, who says since you're not doing bounce check after the append on 38 for the next iteration. Damn. Alright, let's try removing 37. Let's see what happens.
Infinite?
Yeah, I think so. So Okay, so Michael's said the same thing as you. He recommended to comment out this line. Actually, I'm gonna bring back the line I had over here, and I'm gonna comment down this one. Right? Let's see. And we're still getting an error.
Then how about you do? Can you do a if statement before the for loop that says, actually, how could you do that? Where you check the visited test before you go into the for loop? Is that a possibility?
What do you mean?
Like, cause like what I'm thinking is that test case in that if statement, the visited one, is causing that visited one is causing some issues. So is there a way just to test to see if that's wrong or right? If we could check it prior to the for loop starts, and then we'll make sure that okay, if it exceeds, we'll make sure to check if it exceeds out of bounds before we go into the for loop.
Yeah.
Or before the if statement. I don't know where exactly it will be put, but something where you could check it and see like, okay, is it out of bounds? Is it not? And
okay. I don't think it would be possible outside the for loop, because we do need to iterate through the move, so we can like move around.
Yeah. So we
right,
need
but we
can
can do, we can do some like this work, right? And we can do.
You're trying to print out a string or what?
Oh, like this, and we can run it. Yeah, it's giving me an issue here because it does work. Add the visited check inside the other if statement if possible.
Yeah, that was another thing I was thinking is put that if statement inside the if statement.
Oh, here.
Yeah.
Okay. And
then
no worries.
If it's false, then you equate it to true, and then outside of that, you queue append or something.
I think we could do this like this. I think this could work. Not sure, but let's run it. Oh, we got a. You got an infinite loop.
If equals false, then that equals true, and then append. Oh, do you want to put the q.append in that if statement?
Okay.
Can you move over the window a little bit?
Oh, yes.
Okay.
So it's this one right here.
Do equals R. Remember we had it as equals R and equals C in the line 37?
Equals R equals C.
Double incrementing. Oh, look.
I think it has to do with this.
They mentioned double incrementing.
Your X and Y are switched from the initial source in CS. Let me see. Row, source, column. Pop left. Is it? You should swap your RNC when initialized visited. Visited. Initialized visited. RC. You should swap your RC.
So it should be SCSR?
CR? Maybe?
Now, are you talking about line 29, John? Oh, line 25? Swap R and C. Oh.
925. Okay. Let's see. Let's see. Let's run this. Let's see. Not quite. Not quite.
Jonathan says, no, don't do that.
Don't do that. Jonathan to the rescue.
No, still thank you for the input, John. Don't
Line
trip,
39.
Okay, now we got line 39. You're putting X first. Y in is rows should be first.
Is rows. Let's see. Why is rows should be first? Let's see.
Also, appreciate y'all for the input. Should you change it for the other one as well?
Which one?
Line 40 as well?
It's because it bounces here. So let's see. 37.2. Okay, so he's saying to basically change to swap these. So the better swap, just go like this. R. And might as well. Okay. Let's see if this runs. Yeah, you can unify your rows and columns name instead of X, Y, and RC. You're checking R against R and Y against C. Should be swapped. Variables names is something you judge as a good interview. It's really important that you can write readable code. Yeah, I tried doing the X since like X is always like the first one. You go X, right, and then Y. Pop on line 33. Check to make 33. Check to make sure it. Okay, 33. All right. Let's see. I think you can do this. Let's see. Yeah, we get 112021. Wait a minute.
Wait a minute.
Wait a minute. It is working. It is working. It is working. So it is working. Should be sure you think. I think X. Okay, let's see. Do this. It was working right. Bro, this is weird, bro. I'm confused. I don't know what am I doing. I'm just doing stuff.
Dude, that's one of my favorite things too. Is just keep trying everything and until you get it. And then,
when you pop on line 33, check to make sure it is not visited already. 33, check if it's not visited. Okay. Try removing the NY from the visited. NY from the visited. Okay.
Michael's thinking we're double incrementing.
Okay, for sure. Let's go. Let's see. Damn, bro.
Now it's line 41.
Visited.
So change that one. And I'm just a C. I don't know. Honestly, don't know.
Let's see. Double incrementing. All right, we're not out of bounds.
I forgot what our goal was with this problem.
Right now,
I forgot what the goal was. I'm just trying to figure out this right now. And then,
as soon as we figure out this, I think the other ones are easy, for sure. All right, so let's backtrack a little bit. Let's backtrack a little bit and see where we're at
okay.
right now.
Yes, please. I got so
Okay.
caught up with this damn out of bounds stuff, I forgot about the problem.
Yeah. So X, Y. So we pop left, so we get X and Y.
Yep.
Here with positions to check in your bounce checks works. Okay. So let's just follow. Same for the one. Michael, this is there. Okay, now you have to queue with positions to check and your bounce checks works. You confused me there, Michael. You confused me there a little bit.
We might have to do an emergency
call.
phone a viewer.
Phone a viewer. Yeah, I'm down. I'm down to.
We might have to do an emergency phone the viewer, man. Okay. Wait a minute.
Wait a minute. Sure, 1, 2. Okay. Somehow it worked.
What did you change?
So?
What did you do?
I changed this. I changed this because it was YX. I switched it to YX. Like I reverted back.
Okay.
We had an X here, then Y here. Then my columns. Okay. I got a notification from. Hey, I got a notification from one of the viewers.
Michael said he wants to hop on the call.
Okay.
You want to do double whammy?
Ooh. Okay.
I mean, they can both join. It don't matter.
They can both join. Yeah, for sure. Yeah, I'm done.
We might need a phone a viewer. I could bring them in, so you don't have to like show the Discord.
Yeah, no worries.
All right, if y'all wanna, if Michael and Jonathan, if y'all wanna join up, join general, and I could drag y'all.
Yep.
Sorry about that.
No worries.
Phone a viewer time. All right, sure, I have a queue. What does that mean?
Sure, I have a queue. Okay.
Hello.
Welcome.
Are you allowed to talk or no? Or is it? Oh no. Okay. Yeah, you can.
Yeah, can you hear me?
Yeah.
Yes, we can hear you. Yes, loud and clear.
Awesome.
Yes.
So let's see. I can share my screen, or how do you want to do it? Because I don't know if you want me to just straight up give you the answer.
No, you could. I think what we did last time, Jose, was it you just view Jose's screen and then I guess walk him through it in a way.
Yeah, or tell me where to fix or what to type, and I'll do it. Yes, sir.
Isn't that what we did last time or
no? Yes. Okay. I think so too. Yeah.
Gotcha. Okay. So let's see. I mean, there are a few recommendations I'd have just to make it easier to understand.
Yeah.
So first of all, on line 25, visited, instead of having that be like a two-dimensional array, change that to visited equals set and then a pair of parentheses.
So set pair of parentheses like this?
Yeah, perfect.
Yeah, okay.
Okay, and then one thing that I always do for like BFS is I check that things are visited or not visited in the while loop instead of the for loop.
Okay.
So on line 34 here,
Yeah.
get rid of the print statement, and
Yep.
we'll say if x and y are in the set, then we'll continue.
Okay, like this.
Yeah, but x and y should be in a tuple or a tuple.
Line
So,
parentheses.
yeah.
Yep. Okay. Okay. Okay, and then this goes. I just tap it in there, so it can be
Perfect.
fit in. Yep. All right.
And then I would also change. Oh, sorry, no. Don't indent that.
Okay. No intents. All right.
I would also change y, x and y to y and x.
Oh, sorry.
Yeah.
So here, yx.
Yeah, because y refers to your rows and x refers to the columns.
Okay.
Sorry, on line 33 and 34.
33, 34.
Yeah, just like
Y.
from now on, it should be y first.
Okay. Fair enough.
Yeah.
Okay. Yeah.
So, you know, just delete 35 through 41 because I'll walk
We're
you through the.
cooked.
I'm sorry. No,
Bro.
it's gonna be fine. It's gonna be fine. I promise.
Bro, we're cooked, bro.
We got
Whoa,
cooked
whoa, whoa,
by,
whoa, whoa.
we got cooked
Whoa,
by
whoa,
a
whoa.
viewer.
Okay.
Michael, do you want to
Hold
object?
up. Yeah, we don't have to go. We don't have to rip all this out.
We don't have to burn it, but yeah,
I mean, we could
wanna
just
make
do
sure
a
we have the
DFS
right
if
thought
you want,
process.
but like we can have them kind of locked here, I suppose. Like, we're not going for optimal here necessarily.
Sure. I mean, but
In
yeah,
my
so-
opinion, if I can object, is
Sure.
if possible, if we could solve it the way we were trying to, I think it'll be a little bit more beneficial. And then afterwards, we get to see what you would want to do, Jonathan.
Yeah, no, this will use
Is it
like the
sort of
logic
similar?
we had. Yeah. Yes.
Okay.
It's
Yes.
yeah. So if y and x is in the set, then we'll say
Yep.
continue, right? Because we just want to
Okay.
go to the next step.
Yeah.
Sorry. So like the keyword continue. Like I should type continue.
Okay. Continue.
Yeah.
Okay.
Sorry, there's just a bit of.
You know what
screen
that
delay,
does?
I guess.
You guys know what that does?
It'll check it and it'll just continue. That's the key word.
So
It's like
continue-
break, but it'll continue iterating. Instead of jumping out, it just
Oh,
goes back to
okay,
the single
okay.
point.
Okay. I
It'll
see.
jump to line 32.
Okay.
So then, on our next line, we will add it to the set.
Okay. So we're gonna
Set.
do.
We'll say visited.add
Visited append.
.add.
Okay. Dot add.
Yep, and then y and x.
Y and X. Yes, sir.
In parentheses.
Yeah, with parentheses.
Okay. Parentheses.
And then on line 34, instead of saying if it's in set, we'll say if it's in visited.
Okay.
You want to shift 36, indent it back one as well.
Like this. Okay.
Unreasonable right now.
Yep, and we'll get rid of the parentheses after
Um,
visited on line 34.
94. Okay. Yeah. Right here. Yes, sir.
Perfect. Okay. Now, what we're going to want to do is change the image. So
Okay.
we'll say that image at yx is equal to our color.
There we go. Okay. Yes.
Okay. So then we'll go through the directions, right?
Yep.
Move. So we'll say for dy comma dx in move. I'm just using the variable names dy and dx to be
Yep.
able to change it, right?
Yes.
And we can say that new y is equal to y plus dy.
Yes, sir. And I'm assuming we do
And-
the same thing. For
Right.
Okay.
Yep. Perfect.
Yep.
Okay. Then comes our super long if statement.
Yeah.
So we'll say if new y is less than 0 or new x is less than 0.
New x less than 0. Let's do y. So less
And
than
so
0.
this is the opposite of what you guys were doing. So what we're doing here is seeing if it's impossible, in which case we'll go to the next loop. What you guys were doing before was checking if it was possible. So this is just kind of inverted.
Oh, okay. I see. Okay.
So then we'll say if new y is equal to r, or our rows, or yeah.
Okay, so and here in the same if statement, right?
Right. So we just do or.
New. Okay, or.
Yeah, these should all be ors.
Oh, okay. Okay, or new y, it's equal to r.
Yeah.
Okay. Capital R, and then new x
Is equal to c, and there should all be double equals.
Okay, yes sir. Got you. Alrighty.
Then we want to say or new y comma new x is in visited.
New y comma new x.
Yeah, in parentheses.
Okay. Parentheses.
Mm-hmm.
The new y new x, right?
Yes. Yeah.
Equal in.
Voice is love for who, Danish?
In visited, like this. Yes.
Right. Yep.
Okay.
And then last we'll say or image at new y new x does not equal our starting color. I'm not sure what variable name you have for that.
I think we called it pref color.
That works.
And the new x is not equal to pref cut. There we go. Okay, I see.
Then, if any of that is true, then we'll continue.
Yeah. Continue. Yes.
Awesome. Then we'll unindent.
Maybe.
Perfect. What's up?
Yes.
Maybe it's worth noting here, because continue's new, that this continue will jump back to line 40, not line 33.
Right. We're just going
to the
direction. Just going to the direction.
So it goes to the closest for loop per se, or the closest. Yeah.
Mm-hmm.
Okay.
Lexical block, I think, is a technical term if you want. But yeah. Correct.
Lexical block you mentioned?
I've never heard that term before.
Say it again, Mike.
Yeah, lexical block or like lexical
block. I'm writing that down.
Yeah, don't fact check me on that. It's been a while.
I'm gonna fact check you on that.
Then after that if statement, if we're all good, then we'll say q dot append new y new x.
New y and new x, like this, pretty much.
Yeah, but in parentheses.
Parentheses. Yeah, because it's a tuple.
Right.
There you go. Okay.
Then on line 30, instead of having it at 1, 1, we're going to change that to SR and SC, because that's where we start.
SR. Yeah, okay.
And I think that should work.
All right, let's run it. Fingers crossed. Let's see. Okay, so I think this might be a typo of me, of one of my typos. It says if new invalid syntax.
Oh yeah, you have an extra space.
Extra space. Where here?
You have new space X instead of.
Okay, I see. Yep. Thank you. Appreciate it.
Hey Jonathan, someone said derivative mentioned with the dy dx. Don't remind me. I just finished Cal 2.
Okay.
Oh, I see. So that's left over from our old. So just delete that line.
Okay, I got you.
And then we also have a typo on 33. You say it says visited instead of visited.
All right, bro. You're gonna see a lot of typos, dude. My typing is horrible, bro. My typing is bad. Hey, we got it. Okay. All right.
We.
This.
Did you say
No,
we?
bro. Jonathan got it.
Okay.
Jonathan got it.
Yeah,
There you go.
I sent my own solution in the Discord, and it's pretty the same.
All right,
Okay.
but we appreciate it, Jonathan. But
Yeah, no problem.
your knowledge is gonna be tested right here. All right.
All right.
Let's see.
Jonathan.
Let's see.
Nice.
Hey,
Good
yes,
job,
sir.
Jonathan.
Yes, sir. Yes, sir.
All
Damn.
right.
Okay.
Don't ask me to explain it.
We weren't that far. We weren't that far. No lie. We weren't that far. We said
You were close. You were close.
we were close. We were
Jonathan is
close.
him. Michael,
Yes,
My
sir.
I want
my
your
DFS
insights.
was 63, same runtime, 63 milliseconds.
Really?
Really? Damn.
Did you share your code, Mike?
I can.
Yeah, sure.
Yeah, why not?
Yeah.
Would you like to add
And then you
anything,
guys
Mike?
can
I
walk
know
through it.
I
'cause
know you
it's
mentioned
quite different.
something earlier. Is that something you want to do? You want to walk through a different way, or any opinions?
Yeah, sure. So this
Alrighty.
is depth first search.
All right.
So
let's
like
see.
it would take you just as long to implement, and I got to drop off here. But
Alrighty.
I think having you guys walk through it might be really helpful. Like
yes.
trying to understand it, because reading code is something that's also really important.
Alrighty. Yeah. I have your code here. Yeah. For sure. For sure.
And you put the comments.
He put the comments.
Yep. Yeah.
He put the comments.
I don't normally do that.
Nasty.
Damn,
stuff.
bro. He in here. He's in here. Damn. Nah.
All right, I'll be here for questions. I'll let you guys just walk through it.
Yeah. All right. Bet. So, okay. Let me see. Can I copy this and put it on LeetCode so we can have
And
a
this
better
is
view?
some production code right here. It's crazy.
Dude, I know,
This is
bro.
great.
The
This
joke
man
is all the production code I write at work, like there are no comments. This is like above and beyond. The Go is self-documenting pretty much, so you don't really need them.
All right.
I'm gonna be
so-
honest though. I really dislike the number of arguments for the function. That kind of hurts me.
Okay.
Are you
so,
a OOP fanboy? You want them packed into a nice class?
No. I just a function I feel like should have 3 arguments at maximum.
Hey, we got function beef in the call.
we got the function beef.
Function beef. Function parameter beef. It happens.
Nah.
All right, go.
Alrighty.
Let's see.
Let's
read it
see.
through.
Okay, so we have float fill the class. Okay, so say call the walk DFS helper function to modify the image list. Okay, the walk function will modify the underlying array in memory, so we can simply return image after walk return. Okay, so we get an image, a row, column, image, row. Okay,
Yeah.
and the color in a set. So we're gonna
Basically,
return
the
an
only
image.
thing I'm doing is adding a set. So I copied the essentially function signature of flood fill into walk, but I needed to add a set. That's why I kind of made a helper function, because I just need to add that.
Okay.
That's the only thing I'm doing.
All right, fair enough. Yes, sir. So we have the function here, and we say walk target set. Okay. If not, okay. So here you're checking if it's inbounds or out of bounds in this part here, or row column in C. So okay, so this is pretty much kind of similar to our if statement over here. Yep. Then we get a base case, and we return. Okay, if we add it to scene. Okay. If image row is not target, another exit condition, but we want to set this after we add this row compared to the scene set. Okay. So if image at that position is not target, we return. Okay. But if it is, we set to color.
Yeah, so when you get to line 70, like, what assumptions can you make based on the previous exit conditions?
Okay, so first of all, it's inbounds, and it's not seen, right? So it's not a little square that we've visited. And then, and if it's not target, we return, meaning that if it's not like the 1 in this case, right, we return. But if it is 1, right, we go right here. Yes,
Yeah.
we fix it to color. Yeah. Okay.
Nice.
And then here we pretty much we walk up, right, no, up, down, left, right. If I'm not mistaken. Yeah. Okay. I see. Okay. Okay. I see you. I see you. I see you. This is yes. Okay.
This is the depth first search recursive solution. Or
Did you
breadth
want to
first
run
search.
it,
You
Jose?
can do both.
Yeah, I can run it. I can run it. Okay. Okay. Let me see.
There's some kind of formatting issues, but yeah.
No worries. No worries. No, you are good. You are good. You are.
Mike, how you doing, Mike? It's been we talked to you last, when was it, last Thursday or whatever? You say you were out, you got a drink with the boys or something like that?
Oh yeah. I think that was a couple weeks ago because I got
That's-
sick. I was out last week.
You got sick. What
Pretty
happened, man?
bedridden. Just flu
Allergies?
type thing.
Flu?
Yeah. Ugh.
Damn.
Um,
Well, I'm glad you're better, man.
okay, I
Thanks,
think we have
appreciate it. Yeah,
some
good to be back.
formatting issues here, but I think we can.
Yeah, you just highlight all those lines and then type tab.
Yep. Yeah. Okay.
We'll get you. That's a side quest is to get you all on some keyboard shortcuts.
Keyboard shortcuts.
Command A. Looks like you'll need 57 as well.
Oh.
So like 54 to 57, highlight them and type tab. Things like Command A to highlight everything. You get some Option Shift. Basically, Vim key bindings is what we're going for.
Could you find
Bro,
our
I still
GitHub,
get it.
Michael?
Yeah, I did.
Okay, cool.
Log into my personal account without add you guys.
Unexpected indent. I think I'm doing something wrong, Michael. Here.
Let me see if I can get you a cleaner thing to paste. But yeah,
That-
basically.
That return shouldn't be ended. It should be on the same as the self.walk.
Yeah, and then the comments also
okay,
will need to be indented. One, and then the whole thing needs to be shifted back one.
Oh, that's
It's
true.
kind of a mess.
53 down.
53 down.
Mm-hmm.
Okay. I'm sorry, guys. I'm kind of slow when it comes to this stuff.
It's all right. We'll get you there, but
Damn.
you don't have to run it till we're ready. Yeah.
Sorry, no, I
Push
meant
that back.
53 all the way down should be
Okay.
unindented.
53
Oh no, you
all
were
the
right.
way down.
You were right.
Indention impossible challenge.
Damn, but I just give
Yeah,
up
those
anything.
braces are good.
Nah, bro. This is one
It's
thing I
alright,
hate
it's
about
alright.
Beginner
Python, bro.
leak coders get stumped on indentions.
On indentions, bro.
I'll type. Yeah, there we go. Shift
I
tab.
think
And
Mother.
then highlight 60 to the bottom. Sorry. I got this. All right, 60 to the
60
bottom.
to the
highlight
bottom.
all. Shift tab.
tab. Okay.
No, shift tab. So do it twice now.
Okay. Shift tab or just tab 2 times?
Shift.
Hold down shift, press tab, and one more time.
Shift.
There you go.
Okay.
One more in. There you go.
Right there.
Woo!
Like this.
Woo! You scared me, Jose.
Yeah,
Good
we got
stuff.
it.
Nicely done.
All right, let's submit it. Let's see
That
how
was a
it
leak
goes.
code problem itself.
Yes, sir. Okay, I got. Okay, yes, sir. It
Good
works.
stuff.
It works. Good
We'll
stuff.
take it. We'll take it.
Stuff. Of course. Damn.
Mike, any key things we should remember based off the solution that you would like to suggest?
Yes. Always start with a base case when you do recursion. I added you a nice little comment there, but like, if you're thinking of recursion, you have to think, when is this going to terminate? And for that, like, if you put everything as much as you can in the base case, like, you'll see how easy the recursive step is. It's basically that loop from 70 to 72. I'm just walking up, down, left, and right. And the base case handles all the bounds checking, whether it's seen or not, like in the first few lines, and it'll just return if it doesn't pass the condition. So always take care of your base cases.
Alrighty, is
Nice.
yes. Okay. Do you think that makes it easier to work with like recursive, like in general, like working
For sure.
with a? Yeah. Okay.
Yeah,
So-
and it's like a good framework thought when you have a problem. Like you just think of like what are the terminal conditions for this, and those are
Okay.
naturally what you end up putting up there in the base code.
Okay,
Alrighty.
I have one.
Right
I
on.
have one last question. So, if you're
Shoot.
given this in a interview question, is this the type of solution that you would use to solve it? You personally?
Well, personally, I would. Well, first step one, I would kind of talk like interviews are a conversation and insight into how you think. So it's not. I wouldn't just like start coding. I would have a conversation and like firstly I'd
Okay.
clarify the problem, go over the scope, stuff like that, and then I'd say, okay, first things that are coming to my mind are we could use breadth first search or depth first search here. And then I'd go through kind of the pros and cons with them and then say, like, do you want them to go a certain way? If they gave me a choice, I would do depth first search because this is like 10 lines of code. Like, in my opinion, I just can think of it a little easier. But if they had breadth first search, like, that works too.
Okay.
Like, they're the
Okay.
same time and like the complexity is both linear. So
Okay. So like outside of like the approach, you mentioned that you'll keep it conversational based and expressing what you're thinking and your thought process, right?
for sure.
Okay.
Yeah, like a good interviewer will be like you're not just coding in front, kind of like you guys do in the chat. Like it's very much a conversation because ultimately, like you're just trying to show them that how you think. Like they're trying to judge how you think. Like when I do interviews, I'm not like I honestly most of the time don't care if they reach a solution. It's just like I want to see how you think, how you problem solve. Do you go over kind of things that might be a problem before you start coding? Like you sit back and kind of conceptualize the problem, go over some potential edge cases, like things like that, more than the actual implementation.
Would you
But
care
that's
how
just me.
many? Would you care how many parameters we have in a function?
No. I mean, unless you did something like here, you're given like a bunch. But if someone like went out of their way to like unnest an array and test it as parameters, yeah, I'd be like, okay, I don't want to work with you.
Okay.
Okay. Fair
That's
enough,
good to
fair
know.
enough.
Whew, I need to get
Yeah.
that one clear. I just have to
Yeah.
remember that one. No, but that's some good info right
Yeah.
there.
Good advice.
I
Yeah.
appreciate you sharing that.
No problem.
Alright. Yeah.
All right. Well, we'll me and Jose will see if we want to do another problem or not. But I appreciate y'all
Yeah.
for
Yeah. We
for coming in
appreciate
and chatting.
Jonathan and yeah, Jonathan and Michael. We appreciate it. You know, thank you guys for bearing with me because I'm the one typing with my typos and indentations and stuff. I'll like for my interviews, I'm gonna have to like practice a good 2 hours for my indentations. Cause yeah, that's
Well, you won't
one
be
of my
copying and pasting, so
yeah. Okay,
it
that
won't be
is
as
true.
much of an issue.
That is true. That is true. That is true. Nah,
Yeah.
All right,
but no,
guys, I gotta
appreciate it a
hop
lot.
off. It's midnight here on the East Coast, but I'll
All
catch
right.
you on the next one.
Thank
All
you,
right, buddy.
Mike.
Thank you. Thank you
Have
very
a good
much.
day.
Take care.
See ya.
Good night.
Peace.
Thank you,
All
Jonathan.
right. Bye, bye, Jonathan. Thank you. Thank you.
All right.
All right. Hey, that was pretty
good
good.
guys.
Thank you, guys. Thank you.
We got the best community, man.
We have the
Of
best
coders.
It's small.
The best community
It's
of coders.
it's small but good, bro. You get me?
Yeah.
Like you don't need a lot. It's small but good.
It's quality over quantity.
Exactly, bro. Exactly. So
Ah,
thank you, Jonathan. Thank you, Michael, for helping us out, for giving us tips, interview tips. That not only us but the people in the chat can work and use for their own experience. And Jonathan here, helping us out, fixing our code, making it a lot better for the viewers that are seeing, that can understand better. And no, thank you guys for everything. Thank you for the chat. I think now I've seen the new faces. I think Pierre, John are here. So thank you guys. Thank you guys for
Denish,
coming.
they've been here before. I've
Denish,
seen Denish. I've seen
Denish.
Denish
Oh,
here
really?
before. Yeah.
Alrighty. Well,
Correct me
Denish,
if I'm
welcome
wrong,
back.
Denish.
But yeah,
What's up, Kyra Arguelles?
Arguelles.
Arguelles.
What's up? What's up? Alright, bro. Now the
What are you
question
thinking?
is,
What are you
bro,
thinking?
my insane level, bro, is on the 7, bro.
A 7?
My brain is fried.
Dude,
It's
if you're at a 7, I'm at a 9. If you're at a
damn,
7, I have to be higher than that.
bro. My friend, like, I can't think anymore. Like, it doesn't hurt, but I know, like, if I start thinking again, it's gonna hurt. Cause like, it's like a lime. You get me? Like, you squeeze out the juice, right? But like, you keep squishing, but nothing's gonna come. Like, all the juice is gone. You get me? That's where my brain is.
So
It's
like a lime.
like a lime.
Okay.
We're like, we're like all dried up.
Like there's no more flavor, no nothing.
No more flavor, no more juice to squeeze. This is a
Hey,
problem.
Orcus said then that's a 10. That means you might be
that's
out
a
of a
10?
10.
Okay, okay,
Oh,
okay. Put me at a 10. Put me at a 10 then. Put me at a 10.
wow. That is crazy. You
That
got
is crazy.
persuaded. You
I
got persuaded.
for Orcus. Orcus.
Wow.
Damn, bro.
Wait,
Damn.
I'm
What
trying to
about
change
you?
the
How you
color.
doing?
Bro, I like I said, if you're at a 10, what am I at? What am I at? I'm definitely up there with
15?
you. So I'm gonna go down with
Nah, I'm
you.
kidding. You're gonna
Go
down
down
with
with
me?
you. Since the max is 10, I'm gonna just say 10 plus.
10 plus.
10 plus.
Alright, first 10 plus. Damn, first 10 plus. First 10 plus. 50. First 10 plus.
Yeah.
First 10 plus.
But you know what
Of the
that means,
champion.
Orcus? Or maybe you don't know. Once we hit
Don't
10,
know.
we're done. That's
We're
it.
done.
We hit
We're
our
done.
max.
We hit our max. We can't do it no more. I think we've been live for 3 hours. Yeah? Damn.
Damn. Orcus wanted us to end the stream.
Orcus
We
wanted
see-
to set the stream.
We see how it is. We see how it is.
He wants us out. He wants us out.
But damn.
Rip Cairo. Hey, that's true though. Cairo just joined up. We're about to leave.
She's like, I'm back. Or she's like, I'm late, I'm back.
I'm late.
Hey, good thing on YouTube you can scroll all the way back.
You can scroll all the way back and watch it again.
Oh,
Yes,
man.
sir.
No, it was a good stream though. It was a good bounce
was-
back stream. Our last
Yeah.
stream we had to do a quick one because
Yeah,
it was
and
finals
stuff.
week.
Yep,
So
yep, yep.
now
Yeah.
we don't have to really stress over anything just yet. But
Yeah,
oh man, that was a good stream. I like that.
yeah. I like this stream because we went out of our way.
For sure.
We did some dynamic programming, which we avoided. Some graph traversals, which we avoided too. But today I was like, you know what? Let's choose these problems that we're gonna, test us. A little good stream, good 3-hour stream. It's gonna be a long stream for sure. But hey, we're here. We
And Jose
managed
said he's
to-
gonna do the timestamps. So hey,
Oh, that's so
let's
true.
go.
That's so true.
Hey, hey, I don't gotta be doing the timestamps.
Bro, today I had 2 hours doing timestamps, bro. 2 hours, bro.
You spent 2 hours doing timestamps? There's no way.
Well, now we're 30. Now we're 30.
Okay.
Yeah, because I was watching like a little bit of YouTube here and there. I was taking breaks and stuff. Yeah, so yeah.
I see.
But like Garga said, it was a good and healthy stream.
When does the vid
drops?
Jonathan,
That's a question for you, my guy.
I've been slacking, Jonathan. I've been slacking. But we have the ideas there. We already did the content during our stream. It's just a matter of me cutting it up and putting the little effects or whatever I do. But the reason why I'm scared to do it is because the one I did, the last video, the 4-minute video, the speedrun one, I spent 3 hours on it. So that's what's kind of making me hesitant, to be honest, is because I spent 3 hours on it. And that's not solely because of like me like compressing the content into like a 4-minute thing. It's also because my PC, my what's it called? My laptop is very slow, so it took a while. Like it wasn't as fast. It's not as fast anymore. So that's another reason why it took a while. But you're right. Those videos need to get out. But I was telling Jose, hey, at the very least, the base case is that we're streaming weekly. So that's the base case. So we as long as we're streaming weekly, then I feel good. But I also feel bad that I'm not getting those videos out. So I'm gonna be working on it. And I told Jose before the stream, I'm probably gonna set time aside, like 30 minutes here, 30 minutes there, because 3 hours all at once it's very exhausting.
Yep.
So,
Yep.
What was I gonna say? All right, last thing. Jose, hear me out.
Yep.
I want to do another stream.
Ooh.
On Sunday. Are you available?
Eesh.
Are you available?
I'm gonna fill you there. I'm gonna fill you there. I have an event this weekend.
Okay,
I'm busy this weekend.
Okay.
Yeah. That's because I don't want to. I want to for sure. But I'm busy the weekend. I'm thinking next week, maybe Tuesday, right? I don't know if you're available too, right? Tuesday, and then a one on Monday or Tuesday, and one for sure on Thursday.
Okay.
Yeah.
You're gonna be busy that weekend as well?
That weekend, it's my birthday.
Oh, your birthday's coming up.
Hey, weekend
let's
birthday.
go.
Yes, sir.
Jose's birthday's coming up.
Yes, sir.
Damn.
Coming up next weekend.
Next weekend's your birthday?
It's gonna be on Monday. Not next Monday. Monday the 27th. But I think I'm gonna do something Saturday or Sunday.
Okay.
Yeah. So.
Borracho Jose.
Hey.
That's funny.
That's confidential.
That's funny.
Yeah.
Okay, but that's
Hey,
no
thank you,
problem.
Orcus. Thank you.
We could do Monday or Tuesday, and then a Thursday one. I'm pretty sure I'll be clear for that.
Alrighty, yes.
But I think that's all I have to say. I think it was a great stream. I appreciate the new people, the returning viewers as well, and the Jonathan and Michael for joining the chat. Joining the call today. So
yeah, for sure.
I think that was all I wanted to say. I don't know what else. Join the Discord if you want.
That's true. Limited spots.
Limited spots. It's very scarce.
We're running out.
We're running out. Each by the minute, like hotcakes. Yeah. So make sure you get a spot, because once it's filled, we're gonna create a new invite link. So it's not like we're not gonna create a new one, but. All right.
No,
that's about it.
Thank
hey,
you guys.
Your birthday's coming up, and then my birthday in about a month. So we might need to do some birthday streams.
Birthday streams? I'm down.
Birthday streams.
Birthday streams. I'm down for that. I was actually thinking about something like that, but yeah, I'm down.
Some IRL streaming.
Ooh, IRL coding. Ooh, LeetCode.
We'll see what's up, but
we'll see. All right, guys. Yes, sir. All right, guys. Thank you guys for coming in, everybody. Thank you for the chat. Thank you for your help. Thank you so much. We really appreciate your support. Leave a like, subscribe, share, and yeah, thank you guys. And have a some great, wonderful night. Yes, sir.
All right.
Yes.
See ya.
Yeah. Bye.